Welcome, curious minds and sleepy thinkers. You found a soft place to land where the questions are big and the pace is slow enough not to jolt you out of your pillow cocoon. Tonight we're going to tiptoe into one of the most mysterious questions ever asked. How does our Earth truly breathe, and what are the hidden rhythms that shape the world around us? The very air we breathe, the ground beneath our feet, and the vast swirling oceans. We'll gently explore the delicate dance of forces that govern our planet's moods. From the grand cosmic ballet to the quiet stirrings deep within its heart. But don't worry, we'll take it slow. This isn't a race through equations or a sudden plunge into complexity. It's more like floating through a galaxy of ideas with a cup of chamomile tea, allowing wonder to settle over us like a soft, comforting blanket. Imagine for a moment standing beneath a sky that seems to shift its colors and temperament with an endless, unpredictable whim. One day, a gentle warmth bathes the land, the next. A cool whisper drifts through the trees, or perhaps a sudden downpour cleanses the world. Our climate, with its shifting temperatures, its dancing rains, its invisible winds, and the mighty ebb and flow of its tides, often feels like a wild, untamed melody, played with so little discernible rhythm or reason that even those who dedicate their lives to understanding it, the patient weathermen and women, sometimes find themselves chasing shadows. This feeling of constant flux, this beautiful, bewildering unpredictability, whispers to us of the sheer, unfathomable complexity of the systems that cradle our Earth's climate. It's a tapestry woven with so many threads, so many interwoven cycles at play, that trying to grasp exactly why our skies hold a certain hue, why the winds hum a particular tune, or why the tides kiss the shore in a specific way on any given day can feel like trying to hold water in open hands. And as we settle into this gentle contemplation, this deep relevance of our Earth's intricate workings becomes even clearer, especially when we hear the many voices that rise and fall around us, debating humanity's quiet or perhaps not so quiet impact on the very weather we are experiencing. Some voices, like ancient trees rooted deeply in skepticism, seem vehemently opposed to the notion that our gentle human touch or our more forceful human presence has significantly influenced our own climate. They suggest that the Earth has its own grand stories to tell, its own ancient rhythms that dwarf our brief presence. Others, however, speak with the absolute certainty of a rising tide, treating our influence as an undeniable truth, a clear reflection of our actions on the delicate planetary mirror. So where we might softly ask ourselves, does the truth lie in this swirling conversation? If you'll forgive a small playful whisper of a pun, it's time for us together to gently clear the air. We shall embark on a quiet journey, a slow drift across the vast ocean of planetary understanding. We will begin by tracing the grand, almost imperceptible arcs of Milankovitch cycles, those long, patient dances of our Earth's orbit and tilt that unfold over timelines far beyond our grasp, shaping the very seasons and perhaps even the great ice ages that have come and gone like sleepy breaths of the planet. Then we will turn our gaze to the more immediate yet still powerful atmospheric wind patterns, the invisible rivers of air that flow and swirl, sometimes creating protective walls, sometimes breaching them with dramatic whispers of winter. Our exploration will then lead us to consider the silent, profound influence of the sun, our life-giving star and the moon, our constant companion whose gentle gravitational whispers orchestrate the tides and in their intricate dance can bring forth both soothing ebbs and dramatic flows, touching even the innermost workings of our very being. And then we will descend deeper still into the fiery core of the Earth itself, where unseen movements stir the planet's molten heart, influencing the very magnetic shield that protects us from the harsh breath of space, a shield that sometimes shifts and sometimes in a grand reversal decides to swap its polar embrace. Each of these stories, each of these cycles, whether vast or subtle, seen or unseen, plays its part. Each in its own silent way makes a difference to the living, breathing entity that is our Earth. I am your gentle guide, your quiet companion on this journey. And you are listening, not just with your ears, but with your curious heart, to a compilation of whispers about Earth cycles. In our time together, we are going to slowly, patiently unravel exactly why the weather around us is the way it is today, a mystery that unfolds anew with each sunrise and sunset. And most importantly, we will gently ponder whether our climate, this grand intricate dance of elements, is shaped most profoundly by something we can see outside our window, the distant stars, the warming sun, the patient moon, or by something closer, something we can see reflected in the mirror in the quiet depths of our own eyes. So let us begin our journey, not with a rush, but with some big picture thinking, a soft, wide gaze. If we are to truly begin to understand our global climate, this vast interconnected system, we need to start by thoughtfully considering our quiet, humble place in the grand design of the solar system. What we might ask ourselves with a gentle curiosity truly causes the seasons that we are all so intimately familiar with, that paint our world with ever-changing palettes of green, gold, and white. You may already hold a whisper of the answer to this question within you, a memory from a gentle lesson long ago. But as this fundamental truth will tenderly provide the starting point, the very first stepping stone for the deeper understandings that will softly unfold later in our journey, it is worth reviewing it, allowing its simplicity to settle in our minds. Besides, this question, simple as it may seem, is not entirely straightforward, for depending on where you lay your head on this spinning planet, on which patch of land you call home, you may not in fact experience the seasons in the way that many of us do, with their distinct, dramatic shifts. Generally speaking, the seasons as we most commonly know them, with their clear distinctions between warmth and cold, are born from a beautiful, elegant cosmic geometry, our planet's graceful tilt. Imagine, if you will, our Earth, a magnificent blue marble, not spinning perfectly upright as it journeys around its great parent star, the Sun, but rather twirling at a gentle, consistent angle, like a dancer, perpetually leaning slightly as they move in a grand circle. Because our planet rotates at this tilted angle as it embarks on its annual orbit around the radiant Sun, a wonderful thing happens. During one part of the year, one of our planet's hemispheres, either the northern or the southern, will find itself leaning or pointing ever so slightly towards the Sun's comforting embrace. As it leans in, it basks more directly in the Sun's golden rays, absorbing more of its warmth and light, and naturally this hemisphere becomes much warmer, ushering in the gentle days of summer. Meanwhile, its counterpart, the opposite hemisphere, finds itself leaning away from the Sun's direct gaze, receiving the Sun's light at a more oblique angle, like a shy child turning away slightly. This distant posture makes it colder, bringing forth the crisp air and quiet stillness of winter. This elegant perpetual lean, this constant turning of one side towards warmth and the other towards cool, beautifully creates the regular familiar cycle of summer and winter. This effect, this dance of leaning and turning, becomes more pronounced, more dramatic the higher up or lower down the planet you journey, as if the Earth's tilt is amplified at its extremities. Consider for a moment the small, charming Norwegian town of Tromsø, nestled far to the north. Because of its higher altitude, its grand northern sweep, Tromsø, isn't just pointed more definitively towards the Sun during its summer embrace. The very tilt of the Earth is such that from its unique perspective, the Sun never truly dips below the horizon for months during the long luminous summer. It's a land of endless daylight, a perpetual golden hour. Conversely, during a few months in winter, the Sun never truly rises, leaving the land in a prolonged twilight, a soft, hushed darkness. Naturally, this dramatic leaning towards and away from the Sun's direct light produces quite the seasonal variance, a truly profound shift in the world around them, from the vibrant waking days of endless summer to the quiet, star-dusted nights of prolonged winter. Yet, as we drift closer to the Earth's waistline, to the gentle, warm embrace of the equator, this dramatic effect of the tilt gracefully lessens, almost fading into a quiet hum. There at the equator, the tilt of the Earth doesn't truly change the angle at which the sunlight that golden cascade strikes the ground in any truly significant way. The sun's rays, whether in July or January, always arrive at a relatively consistent, direct angle, like a painter's brush, meeting the canvas head-on. And as such, the Earth at the equator doesn't seem to notice much temperature variation. The seasons dissolving into a perpetual warmth, a gentle, consistent embrace of the sun. It is, you see, all just a question of angles, a subtle ballet of light and surface. Is the sun's golden light hitting the ground dead on allowing its precious rays to be at their most concentrated, their most powerful, like a focused beam? Or are they instead hitting at a more oblique angle, a glancing blow where the same number of life-giving rays are in effect smeared over a much larger area, gently diluting their overall power, their warming intensity? The answer to that soft, profound question can make an immense difference on the local temperature, and this elegant interplay of angles is a very big part of why the majestic Arctic, with its shimmering ice and vast white landscapes, is so much colder than the vibrant, sun-drenched equator. However, as we gently turn our thoughts to the deeper mysteries, did you know with a soft spark of surprise that the tilt of the Earth, this crucial angle we just spoke of, isn't static, isn't perfectly fixed in its dance, nor is it the sole celestial whisper about our planet's grand orbit that gently influences how warm or how cold our corner of the cosmos truly feels. Imagine for a single fleeting second the beautiful simplified model that many of us are familiar with, a vision of our Earth diligently orbiting the sun in a nice neat circle lying perfectly flat to the grand ethereal plane of the solar system, like a perfectly balanced top spinning on a smooth, invisible table. In this serene model, we, the Earth, circle our sun, our great beacon of light, solely because of the sun's immense unwavering gravity, its invisible hand holding us close. Yet this comforting model, while beautiful in its simplicity, is in reality far too basic, far too quiet to capture the true symphony of forces at play. In the grand cosmic truth, the sun, our magnificent star, is not the only source of gravity, that invisible tether gently pulling at us, tugging at our very being. Though it is undeniably the biggest, the most powerful conductor of this gravitational orchestra, many of the other planets, our distant siblings in this solar dance, also exert their own subtle pulls and gentle tugs upon us. Consider for a moment the particularly large ones, the giants of our cosmic neighborhood like Jupiter, with its swirling storms and colossal mass 318 times the size of our own small planet. Or Saturn, adorned with its magnificent rings, a graceful behemoth 95 times our size. These giants, in their majestic orbits, exert their own profound gravitational whispers, their own silent nudges, and in a beautiful reciprocity, we in turn exert our own tiny imperceptible pulls upon them, a delicate interwoven web of mutual influence. As these planets, each a unique dancer, gracefully rotate at different speeds around the sun, their constant pulling and releasing their waxing and waning gravitational embrace creates a celestial dance far more intricate, far more beautifully complicated than a simple solitary circle. It is a choreography of unseen forces, a symphony of pushes and pulls across the vast cosmic stage. This ceaseless interplay of increasing and lessening gravity, this gentle give and take, has many different subtle effects on our planet's very being. It quietly influences the delicate angle of our tilt, that crucial lean that brings us our seasons. It shapes the graceful curve of our orbit, transforming it from a perfect circle into a slightly elongated ellipse. And in an even more profound way, it gently influences the very plane in which our planet and its solar siblings conduct their grand dance around the sun, causing it to subtly rise and fall almost like a slow-breathing chest. Broadly speaking, these vast interwoven variables, these subtle cosmic nudges, have over aeons stabilized into grand predictable rhythms into recurring patterns that we, in our modern understanding, have come to call cycles. These profound long-term cycles, these fundamental rhythms of our planetary existence, were first described with remarkable clarity and insight by a patient and brilliant Serbian geophysicist and astronomer named Milutin Milankovic. He unveiled their elegant logic to the world in 1920, and in honor of his pioneering work, these grand orbital rhythms were quite rightly named Milankovitch cycles. The very first of these magnificent cycles that I wish for us to gently unravel, to slowly bring into the quiet focus of our minds, is the changing shape of our Earth's orbit, the subtle transformation of its path as it endlessly circles the sun. Imagine, if you will, over the course of an immense, almost unfathomable period of 100,000 years, the Earth's graceful orbit around its radiant star, the sun undergoing a slow, beautiful transformation. It becomes first more elliptical, stretching out like a gently elongated oval, and then, with equal slowness, it becomes less elliptical, drawing back in towards the comforting perfection of a circle. Naturally, if our orbit, our quiet path through the cosmos, is closer to that of a perfect circle, our distance from the sun, our constant source of warmth and light, remains relatively consistent throughout our year. It's like being in a room where the light source is always the same distance away, providing a steady, even glow. In such a phase, we receive roughly the same amount of sunlight, the same gentle embrace of warmth all year round, leading to more moderate, less extreme seasons. However, when our orbit, our cosmic pathway, gently begins to stretch and become more elliptical, a subtle shift occurs. Suddenly, there are distinct parts of the year, specific moments in our journey where we find ourselves notably further from the sun, like moving to a distant corner of that room, and naturally during these periods, we become cooler, experiencing a gentle chill. Conversely, there are other times when our journey brings us closer to the sun, to the heart of its warmth, and during these closer embraces, we become warmer, feeling a more direct, intense heat. As it gracefully happens, the perihelion of the Earth's orbit, that special intimate moment where we find ourselves closest to the sun, occurs roughly around January 3rd each year. It's a quiet whisper of warmth in the heart of winter for many. While the aphelion, that distant, expansive moment where we are furthest away, usually unfolds around July 4th, I speak to you from the gentle, often cloud-draped lands of the UK, which means for my hemisphere, January is a time of quiet winter, a season of soft frosts and longer nights. So for me, this whisper of closeness to the sun in January is quite a nice, surprising embrace, a gentle tempering of the winter's chill. Though we are at this very moment in a phase where this grand cycle of the Earth's orbit is leaning more towards circularity than ellipticity, like a pendulum gently swinging towards its midpoint, we still experience a noticeable 7% difference in the sheer amount of sunlight, that precious energy that we receive in January compared to July. This subtle yet significant sunlight difference means that the winters in my northern hemisphere, while still carrying their traditional chill, are in fact ever so slightly warmer than they might otherwise be, softened by that January closeness. And in turn, our summers, those long golden days, are subtly milder, tempered by the July distance. In the southern hemisphere, a different story unfolds, a beautiful mirror image of our own experience. There, the reverse is true, because they are experiencing their summer during this warmer, closer phase of the orbit. Their summers become even warmer, more intense, almost amplifying the sun's embrace. And their winters in turn become colder, a deeper chill settling over the landscape during their time furthest from the sun. And this, remember, is just at this relatively circular stage of the grand 100,000-year Milankovitch cycle. As the Earth's orbit, in its slow, majestic dance, eventually stretches and becomes more profoundly elliptical, that gentle 7% sunlight difference, that subtle whisper of change, transforms into a dramatic 23% difference. Quite significant, you might softly think, a truly profound shift in the planet's daily embrace of sunlight. This might at first glance seem overall a little unfair on our southern hemisphere friends, like a cosmic favoritism. The northern hemisphere, in this particular orbital alignment, appears to benefit from this cycle, which seems to gently stabilize its seasons, keeping them within a more temperate, predictable range. Meanwhile, the very same cycle seems to conspire to make the southern hemisphere's seasons more extreme, swinging wildly between intense heat and biting cold. But do not worry, dear listener, for as we shall soon see, another grand elegant cycle is already gracefully at play, patiently working to bring things full circle, to re-establish a beautiful cosmic balance in the Earth's grand intricate dance. This current familiar seasonal rotation, this annual turning of warmth and cool, happens because at this moment in time, the Earth's tilt, that crucial lean we spoke of earlier, is relatively consistent as it embarks on its annual orbit around the Sun. Except in the deeper truth of the cosmos, it isn't truly consistent. Little by little, with an almost imperceptible slowness, the very angle at which the Earth's axis is rotating, the invisible line around which our planet spins is changing too. It moves with the grace and precision of a quiet artist, as if it were drawing a vast, sweeping circle on the canvas of the sky, high above it. This slow, majestic tracing, this grand celestial artwork, unfolds in a cycle that endures for an immense 26,000 years. One gentle upshot of this grand cosmic ballet is that, while our axis, the invisible spindle of our planet, is currently pointing its unwavering gaze towards the North Star, that steady beacon we call Polaris, this will, in the vast stretches of cosmic time, eventually no longer be the case. Over aeons, with the steady turning of this cycle, our axis will gently shift its gaze, pointing its silent attention at different stars, new celestial guides, before, eventually, with graceful precision, circling back to point its knowing finger at Polaris again, completing its long patient journey. The other equally profound upshot of this slow, majestic axial procession is that in approximately 13,000 years, a blink of an eye in cosmic terms, but a vast expanse for us, the northern hemisphere, our familiar home will find itself experiencing its summer, its season of warmth and light, in what we now know as January. Imagine a midwinter Christmas, suddenly bathed in summer sun, and in a beautiful reciprocal twist of fate, the southern hemisphere will be the one welcoming a crisp, white Christmas, their summer days, now nestled in our current winter. So then it will be our turn, we in the northern hemisphere, to experience a more profound, a more dramatic seasonal variation, a deeper swing between summer's embrace and winter's chill. While harsher winters with their biting cold and endless snow are certainly unpleasant, a challenging but temporary guest, at least they, like all seasons, gracefully retreat, after a few months giving way to the gentle promise of spring. But this, dear listener, is nothing compared to the grander, more profound whispers of change that Milankovitch cycles can bring. For there are Milankovitch cycles that orchestrate winters that do not last for mere months, but for thousands upon thousands of years, a profound, lingering chill that reshapes continents. Or to speak with a little more cosmic accuracy, there are Milankovitch cycles, these patient, powerful architects of climate, that gently, yet inexorably, help to cause the vast, awe-inspiring phenomena we know as ice ages. We, with all our modern knowledge, still do not fully grasp the intricate symphony of reasons, the complete dance of forces that allows ice ages to come and go like great slow breaths of the planet. There are numerous theories, whispers of understanding that attempt to explain these grand shifts. However, it must be noted with a sense of profound wonder that some of the immense 100,000-year spans during which these ice ages settled upon the Earth align themselves with an almost perfect, elegant precision with the very same 100,000-year Milankovitch cycles we have just begun to explore. It's as if they are two harmonious melodies perfectly interwoven in the cosmic symphony. For instance, there is a cycle whereby the grand plane on which the Earth gracefully rotates around the Sun, our cosmic dance floor, subtly rises and falls almost like a slow-breathing chest over the course of another 100,000 years. This gentle change in its orbital inclination, this quiet vertical sway, does not at first glance obviously explain why it is that the Earth would be gradually getting colder or warmer. After all, the Earth is still maintaining roughly the same average distance from the Sun, its source of life. However, this particular cyclical movement lines up so perfectly, so elegantly, with the precise time periods when ice ages were patiently occurring over the last 800,000 years, a vast stretch of planetary history, that scientists with a sense of quiet conviction conclude that there must be a profound, undeniable connection. Perhaps they gently muse a veil of cosmic dust, lying patiently in the very plane of Earth's orbit, subtly blocks out some of the Sun's precious warming sunlight. When we are at one particular inclination, like a sheer curtain drawn across a window. But then it is not in the way allowing the Sun's full embrace when we are at another inclination. This subtle cosmic filter, this whispered interaction with interstellar material, could go some gentle way toward explaining the mysterious recurring occurrence of ice ages during these immense time periods, a beautiful speculative answer to a grand question. Whatever the precise interwoven case, there is at least one other cycle, another profound rhythm of the Earth that quietly influences the arrival of ice ages on our planet. And this perhaps might just be the most important for us to gently consider today in our present moment. It is the subtle yet powerful tilt of Earth's rotation. I already mentioned earlier in our quiet journey that this axis of tilt, this invisible line around which our planet spins, gracefully rotates around the planet, drawing its vast patient circle in the sky. But it also, in a beautiful complexity, changes the very angle at which it does this, like a dancer adjusting their lean. Over the course of a long patient 41,000 years, it gently alternates between a lean of 22.1 degrees and a more pronounced lean of 24.5 degrees. At this very moment as we speak, our planet's tilt rests at 23.4 degrees, and it is ever so slowly declining. You might, with a gentle sense of optimism, think that this slow, steady lessening of the tilt is a good thing, a promising sign. Surely the smaller the angle of tilt, the less extreme our seasonal temperature variations might become, and the warmer our winters those chilly guests will eventually feel. Surely that comforting thought suggests a more moderate climate is a good thing for avoiding the vast creeping embrace of ice ages. But here is where the Earth's delicate logic can surprise us, where the wisdom of the planet twists our expectations. Surprisingly, it is quite the opposite. If left entirely to its own devices, if our planet were allowed to continue its current, slow, subtle lessening of tilt, unimpeded it would, with a quiet inevitability, lead us into another grand spreading of the vast reflective ice sheets and a slow, patient cooling of the entire planet. This profound shift, this return to a deeper chill, would reach its gentle yet undeniable peak in approximately 9th of 800 years. And here lies the subtle paradox. It is not the harshness of the winter, not the biting cold, that causes this relentless spread of ice, but strangely enough, with a quiet poetic irony, it is the very mildness of the summers that unlocks this frozen transformation. You see, when winters with their gentle snowfall occur, pristine white snow gradually builds up at the majestic tops of mountains and in the quiet, eternally cold polar regions of our Earth. In warm, generous summers, this accumulated snow, kissed by the sun's direct rays, tends to melt away gracefully, returning its liquid embrace to the rivers and oceans. However, if the summer, instead of being warm and melting, is mild enough, just a little less intense, a little less melting, then some of that precious snow, that pristine white blanket, lovingly sticks around. It lingers, becoming a more permanent feature of the landscape, like a shy, enduring guest refusing to leave. This icy snow, this persistent winter guest, is of course brilliant white in color and wonderfully reflective. This beautiful property means that sunlight, that precious cascade of warmth and energy, has a tendency to gently bounce off it, to be flung back into the vast, indifferent expanse of space, rather than being absorbed by the dark welcoming Earth beneath. This in turn means that if the Earth, our vibrant blue home, becomes increasingly covered with these vast reflective sheets of ice, it actively begins to cool itself even further, like drawing a white curtain that keeps the heat out. And this self-reinforcing process, this elegant chilling feedback loop, thus creates conditions for even more ice to form, for the frozen embrace to deepen. In more than one gentle sense of the word, this profound interaction is a beautiful yet chilling snowball effect, where the very presence of ice encourages more ice in a quiet, relentless march. We are at this very moment in our planet's grand story, in what is known as an interglacial period. It is a brief, precious moment of warmth, a gentle respite that typically lasts for a few tens of thousands of years or so, bravely interspersing and temporarily dispersing a deeper, more general long-term cold trend of the Earth's natural climate. If it wasn't for this current, fleeting, warmer uptick, this gentle surge of heat, we would actually, in the grand scheme of things, be in an ice age right now. And from a strictly technical perspective, from the cold objective view of planetary science, we actually are in an ice age, just one that we, in our brief human lives, are not fully noticing or fully experiencing its icy embrace. Imagine if it wasn't for this briefly warm interglacial period, this fleeting embrace of warmth, mankind, as a species, would have experienced the chilling presence of ice, vast continental sheets of it, across the entire history of its existence, a world perpetually locked in a frozen grip. But thanks to the patient, unwavering dance of the Milankovitch cycles, that precious brief period of warmth, this delicate interlude will someday inevitably gently end. Then winter with a capital W will truly come, not just for a season, but for millennia, reshaping our world in its icy embrace. Of course, dear listener, this profound thought, this quiet certainty of a returning chill, is based on the assumption that Milankovitch cycles are the only or the primary factors that gently influence global temperatures, the grand arbiters of Earth's climate. And while broad trends, those immense whispers of change lasting 100,000 years, and the interspersing upticks of warmth arriving every 41,000 years, are indeed demonstrable and wonderfully consistent in parts of the fossil record. Like ancient fingerprints etched into stone, the precise location and subtle orientation of our planet in its grand cosmic dance are, as we are beginning to understand, not the only thing that truly matters. No, the silent, pervasive levels of CO2 and methane, those invisible blankets that hug our atmosphere, are also powerful driving forces, quiet yet profound sculptors behind global temperature fluctuations. And if we, in our human endeavors, are not careful, if we do not tread gently upon this delicate balance, then just as a grand ice age can slowly, inexorably build up with a profound snowball effect gathering momentum and chilling our world, so too can the stripping away of ice, the rapid melting of those vast white expanses, happen in precisely the same way, but in a dramatic accelerating reverse. Less ice, you see, means less reflection of the sun's precious warming light, which in turn makes things overall warmer, creating conditions for even less ice, still in a self-reinforcing spiral of melting. If Milankovitch cycles were the only factor in action, the sole conductors of Earth's climate symphony, then we as a species are in the long cosmic view in for a cold future. The Milankovitch cycles in their current patient dance are mostly working to gently stabilize the Earth's system, to hold it in a delicate balance. This leaves us for now in a temperate, relatively even temperature zone, a gentle embrace of warmth and mildness. However, there will come a time, an inevitable turn of the cosmic wheel, when these very cycles will conspire to make temperatures both scorching hot and biting cold more extreme, pushing the boundaries of what we now experience. We would do well, dear listener, to keep these grand patient cycles in mind, to remember their subtle, profound influence. For Milankovitch cycles are in it for the long haul, their whispers echoing across millennia. Winter is coming, as they say in the old stories, the grand narratives of imagination. It might not be coming for a long, long time, an expanse of years beyond our current imagining. But one day, our beautiful planet, our vibrant home, will indeed face winter again. A winter of a different, grander scale. Life on Earth, in its intricate beauty, is truly full of cyclical variations, a never-ending dance of recurring patterns. We experience the comforting rhythm of day and night, the graceful changing of the seasons, and the mighty predictable ebb and flow of the tides that shape our coastlines. Many of these profound changes, these daily and yearly dances, happen over relatively short periods, unfolding within the span of our human lives, and can be predicted with remarkable precision, a testament to our growing understanding of the cosmos. But other cycles, far grander and more patient, quietly affect our planet over immense, sprawling intervals, periods of time so vast that they can be trickier to forecast their whispers, almost imperceptible in our brief moments. Milankovitch cycles, for example, play a profound, undeniable role in the long, slow occurrence of ice ages, those vast blankets of white that have periodically covered our Earth, gently interrupted by warming intervals, brief sighs of warmth. But given their vast timeline, their almost unimaginable expanse across aeons, it is in the humble scope of our own lives quite unlikely that we will be profoundly affected by them in any immediate noticeable way. Yet, as we transition from the grand, almost geological rhythms to those that beat a little faster, a little closer to our daily lives, there is one particular climate cycle, one powerful, pervasive rhythm of our Earth that most definitely will affect you, dear listener. It is a dance of the Pacific, yet its echoes reach every corner of our globe. It is the El Niño Southern Oscillation, better known by its simpler, more evocative names, El Niño and La Niña. While these powerful interconnected phenomena gracefully originate in the vast, shimmering expanse of the Pacific Ocean, their profound impacts, their far-reaching whispers are felt nearly everywhere on Earth. From the parched lands to the flooded valleys, from the gentle breezes to the raging storms, their influence extends like an invisible net. And by some accounts, the strongest, most dramatic effects of this Pacific dance are becoming more common, more pronounced in the last few decades, as if the volume on their melody has been subtly turned up. In recent memory, some of the destructive consequences of this powerful cycle have been stark reminders of its reach. Widespread flooding, the quiet despair of drought, the tragedy of famine, and the mass die-offs of marine life, a silent, profound suffering beneath the waves. Indeed, a particularly severe El Niño, a forceful whisper from the Pacific in 1998, caused an estimated 16% of the world's vibrant coral reefs to simply fade away, to die a quiet, devastating death. This single event, this powerful surge of warmth, tragically kicked off a cataclysmic mass bleaching event, a silent, ongoing crisis that persists even to this very day. The El Niño Southern Oscillation, or ENSO, is truly global in its reach, and without a doubt, its profound influence will in some way touch your life, dear listener, even if you are far from the Pacific's embrace. So what we might softly ask ourselves are El Niño and La Niña. Why are these two seemingly opposite phenomena so intimately linked, like two sides of the same ancient coin? And what are their vast interwoven global impacts? In our second stop on our tour of Earth cycles, our gentle exploration of our planet's secret rhythms, it's time to quietly find out if you find yourself thinking that the name El Niño, with its soft Spanish cadence, sounds more like a gentle folk story, a hushed legend whispered through generations, than a stern scientific phenomenon. Then you are in your beautiful intuition, truly onto something. For during the quiet, simpler times of the 17th century, patient fishermen casting their nets along the coasts of South America, particularly off Peru, began to notice something rather peculiar. They observed recurring periods of unusually warmer ocean water, a gentle, unfamiliar embrace from the sea, which to their dismay coincided with noticeably poor fishing, as if the bounty of the ocean had suddenly retreated. These periods, these mysterious shifts in the ocean's temperament would always seem to peak around the joyful festive time of Christmas. And so, with a quiet reverence and a touch of poetic charm, they called it El Niño de Navidad, which beautifully translates to the boy of the Nativity. Or more simply, the Christmas child, a gentle nod to its annual appearance around that sacred time. It wasn't until much later, in the late 19th and early 20th centuries, that the patient, curious eyes of scientists began to gently connect a wide variety of seemingly disconnected regional events. Odd whispers of weather anomalies scattered across the planet, like individual unrelated notes in a vast, silent symphony. They began to notice patterns, droughts in one land floods, in another peculiar shifts in temperature far from the Pacific's shores. And by the mid-20th century, with their tireless dedication, they had made a profound discovery. These weren't, they realized, mere isolated regional occurrences, like solitary drumbeats. No, they were in fact distinct phases of a grand global cyclical phenomenon, an immense interwoven dance of ocean and atmosphere, which they aptly named the El Niño Southern Oscillation, or WENSO. This vast, intricate ENSO system fluctuates with an average interval of about 5 years, though its rhythm, like a living, breathing thing, can be wonderfully unpredictable, sometimes taking anywhere between 2 and 7 years to complete its full cycle. We, with our modern instruments and patient observations, have now been diligently tracking these powerful cycles for many decades, documenting their every ebb and flow. But in the quiet wisdom of the Earth, they have of course been around for much, much longer than that, shaping our planet's moods through countless eons. To truly understand why the El Niño Southern Oscillation occurs, to grasp the delicate machinery behind its powerful effects, let's first gently peer into what happens in the vast, shimmering expanse of the Pacific Ocean. Under what we might call normal conditions, the baseline rhythm of its daily life. Under these usual circumstances, invisible, persistent winds dutifully blow along the equator, moving with a steady, unwavering force from east to west. This tireless westward journey of the winds is a beautiful, elegant product of the Coriolis effect, that subtle, powerful force caused by the Earth's majestic rotation. Here's a little fun fact, a small whisper of cosmic truth. If our Earth didn't rotate, if it were a stationary ball, then air driven purely by temperature and pressure would simply circulate in straight lines, moving from north to south, flowing gently from the high-pressure icy poles to the warmer low-pressure region of the equator, a simple direct transfer of heat. As it gracefully happens, air does indeed circulate off the poles, descending and moving towards the equator. But here's the beautiful twist: it doesn't travel in a straight line. Instead, as it approaches the equator, it bends, it gently deflects, caught in the invisible embrace of the Earth's spin. This creates a vast circumferential band of moving air that extends approximately 30 degrees north and south of the equator, a region sometimes known as the horse latitudes, a quiet ancient term that speaks of bygone sailing days. In the northern hemisphere, the air caught in this rotational dance gently deflects to the southwest, as if nudged by an invisible hand. And in the southern hemisphere, a mirror image unfolds as the air gracefully deflects to the northwest. This persistent, powerful channel of westward moving air, these invisible rivers in the sky, are beautifully known as the trade winds. And it turns out, with a quiet sense of historical charm, that they weren't just vitally important if you happened to be a swashbuckling pirate navigating the high seas in the 18th century, chasing adventure and treasure. They are, in fact, fundamental to the very breadth of our planet's climate. As these trade winds, these steadfast westward currents of air, dutifully blow across the vast Pacific Ocean, they perform a subtle yet profound act. They gently drag the sun-warmed surface water from the coasts of South America, nudging it westward, patiently, pulling it across the ocean towards distant Asia. And as this warm, inviting water gracefully moves west, a beautiful balancing phenomenon occurs beneath the waves. Colder, deeper water rich with the Earth's hidden nutrients quietly rises to replace it, like a gentle, unseen hand pushing from below. This vital process, this upward surge of life-giving water, is beautifully called upwelling. This cold, upwelled water is incredibly rich in nutrients, the very sustenance that feeds the microscopic phytoplankton, those tiny green meadows of the ocean. And these phytoplankton, in turn, form the foundation, the very first note of a vibrant symphony of marine life, supporting vast ecosystems of fish and everything that feeds off them, from the smallest krill to the largest whales. So, as you can imagine, a sudden shock to this delicate interwoven system, a disruption of this natural harmonious flow, would have a major domino effect on the thriving tapestry of marine life echoing through the ocean depths. If this then is what normal healthy conditions look like in the vast life-giving expanse of the Pacific Ocean, then think of El Niño, dear listener, as a profound disruption of that normal, a gentle yet powerful unraveling of that familiar pattern. During an El Niño event, the steady patient trade winds, those reliable westward currents begin to weaken their invisible force, subtly diminishing. As they slow down, as their eastward pull lessens, the warm water that would normally be flowing dutifully towards distant Asia begins instead to build up, to gather like a gentle pool near the coastal Americas. This unexpected accumulation of warmth results in significantly less upwelling of cold, nutrient-rich water, that vital surge from the deep. This in turn creates a vast zone of unusually warm air and water further east in the Pacific, a gentle, pervasive warmth, where normally there would be cool, invigorating currents. With less upwelling, the delicate balance is disturbed. The fish that depend on the phytoplankton, the very foundation of their food, must either migrate to cooler, richer waters, or sadly, they perish, their lives quietly fading. This Pacific shift, this warming of the waters, also causes the great Pacific jet stream, that powerful river of air that gracefully crosses North America, to move south from where it normally occurs. As a direct result, the northern United States and Canada tend to become warmer and noticeably drier, their landscapes thirsting for rain. Whereas the Gulf Coast and parts of the coastal South America, particularly Peru and Ecuador, receive their wettest months, their most profound downpours, from April to October. And during more severe El Niño years, the rain and resulting flooding in those regions can be truly catastrophic, a force of nature unleashed. Remember the severe El Niño of 1997 to 1998, devastating floods bombarded Peru, their waters rising to collapse bridges and bury entire shantytowns beneath a meter-thick layer of mud, a tragic testament to the raw power of the weather. In total, 250,000 people were displaced from their homes, their lives uprooted by the swirling waters. The region of Tumbes, usually a parched, arid landscape, received an unbelievable 16 times its average annual rainfall, a deluge beyond imagining. But the story of El Niño does not end at the Americas' shores. Outside the Americas, this powerful Pacific whisper sets off a cascade of domino effects, a series of profound interconnected changes that significantly alter weather patterns worldwide, like ripples expanding across a vast pond. The increased rainfall in South America typically coincides with a chilling predictability, with a pronounced period of severe drought in South Asia and Australia, lands far distant from the Pacific's embrace. Severe famines have been tragically recorded in India, their fields parched and barren, and a delay in Australia's monsoon season. Its life-giving rains can lead to massively destructive bushfires, vast infernos that sweep across the land. Due to its immense expanses of grassland, Australia's bushfires are, with a sobering truth, some of the most destructive on Earth, transforming vibrant landscapes into charred, desolate stretches. And even now, as we speak, there are already quiet concerns about a potentially devastating event that could occur late in 2023, a whisper of a future threat. Leaders with understandable worry are preparing given recent warming trends. You may remember that in 2020, in a non-El Niño year, bushfires tragically wrought nightmarishly apocalyptic scenes, leaving 50 million acres of land charred to a crisp, a silent, vast graveyard of trees. Australia, in its very essence, is a literal tinderbox over which El Niño, in its powerful manifestations, looms like a proverbial flamethrower, ready to ignite the landscape. So, local officials are wise indeed to prepare for the worst, to ready themselves for the dance of fire. On a global scale, the average surface temperature during an El Niño event subtly rises by about 0.1 degrees Celsius, a small number that belies a profound impact. But not all El Niño events are severe. Not all are powerful, overwhelming forces. Some, in their gentle unpredictability, can be rather mild, a soft whisper rather than a roar. This is something to quietly keep in mind before you might feel the urge to hit the panic button, to succumb to worry. The average El Niño lasts from 9 to 12 months, a significant period, but on rare occasions, these powerful warming events have lingered for years, extending their embrace across multiple seasons. The world's climate, dear listener, is a profoundly complex system, like a vast, intricate clockwork responding to a multitude of subtle inputs. So the effects of El Niño are best understood as relative to what the baseline, the normal conditions, would otherwise be. This is precisely why no two El Niño years are exactly alike, each a unique expression of the Earth's delicate interwoven systems. Now let us turn to the opposite side of this vast, powerful El Niño Southern Oscillation, to its cooler, quieter counterpart, La Niña. If El Niño with its warming embrace is a hot event, then La Niña in its balancing wisdom is a cool one, a refreshing breath. Though it must be noted that some regions do paradoxically experience warming even during La Niña. As I mentioned earlier, El Niño occurs when the equatorial trade winds slacken, when their westward pull diminishes. But during La Niña, a different story unfolds. The trade winds become even stronger, more resolute in their westward journey, as if infused with renewed purpose. Think of El Niño as a profound disruption of normal, a deviation from the familiar path. And then think of La Niña as normal, plus an intensification of the usual patterns, a turning up of the volume on the Pacific's regular rhythm. During La Niña, the trade winds infused with this extra strength blow even more warm water from the coasts of South America, pulling it with greater force towards distant Asia. This robust westward pull, this increased flow of warmth away from the Americas, results in even more upwelling of cold, nutrient-rich water near the Americas' coasts. For the patient-waiting fisheries, this abundance of life-giving nutrients can quite literally produce a feeding frenzy, a joyous boom beneath the waves. And if you happen to be a salmon, sleek and powerful, then during La Niña, you are indeed in luck, for the conditions are perfect for your thriving. During La Niña, cold water species like salmon will, with adventurous spirit, venture into typically warmer waters where they ordinarily cannot survive, finding new cooler havens filled with food. The same is also delightfully true of squid. Those mysterious, elegant creatures of the deep, in case you, dear listener, happen to prefer them. Meanwhile, in Asia, a different whisper arises. The influx of warm equatorial water, driven by the strengthened trade winds, produces wet, verdant conditions, a beautiful contrast to the parched drought often experienced during El Niño. This leads to a noticeable spike in tropical cyclones, those swirling storms of wind and rain which bring both life and sometimes destruction to the region. In North America, the great jet stream, that invisible river of air, is pushed further north than usual, altering the delicate balance of weather. This shift causes quiet, persistent drought in the southwestern United States, their lands yearning for moisture while bringing much-needed rains to the Pacific Northwest, blessing their lush forests. In 2022, a powerful La Niña event tragically exacerbated a mega-drought in the southwest United States, pushing it to become the worst in 200 years, a sobering testament to the profound reach of these natural cycles. Now with all this talk of trade winds and jet streams, those invisible currents that shape our world, you might be gently wondering how La Niña, with its subtle influence, affects hurricane season. Well, depending on where you lay your head, the news, dear listener, is either a quiet whisper of good fortune or a more somber sigh of concern. The Atlantic, that vast, restless ocean, often experiences a much more severe hurricane season during La Niña. This is because the northward shift in the jet stream produces greater atmospheric instability in the southern Atlantic, creating conditions ripe for the birth and growth of powerful storms. But the Pacific Basin, a mirror image of the Atlantic, actually sees fewer hurricanes, a quiet sign of how drastically different these regional effects can be, how the same global cycle can paint such varied pictures across our planet. Just don't get too complacent. Pacific dwellers, for El Niño in its powerful embrace has the opposite effect, bringing more storms to your shores. Meanwhile, in Pacific coastal South America, where we began our story with the fishermen naming El Niño, you certainly won't see the warm, comforting Christmas-time waters that once prompted those patient seafarers to dub it El Niño de Navidad. Indeed, there's a quiet historical reason why fishermen once called La Niña el Viejo, or the old man, for during La Niña, the weather in Peru and Chile turns noticeably colder and drier, sometimes producing severe lingering periods of drought, a parched landscape in contrast to El Niño's floods. Brazil's north, on the other hand, a land of vibrant life, becomes wonderfully wetter during the months from December to February, blessed with abundant rains, and the lowlands of Bolivia, in their gentle expanse, can receive catastrophic flooding, a testament to the sheer volume of water that can descend during this phase. In Africa, the conditions during La Niña years are basically the reverse of what they are during El Niño, a beautiful balancing act. East Africa tends to experience drier than average conditions, their lands yearning for moisture, whereas the South tends to be wonderfully wetter than average, receiving nourishing rains. So, dear listener, where are we now in this vast, intricate ENSO cycle? As of October 2024, the patient observers at the National Oceanic and Atmospheric Administration, or NOAE, have quietly reported that our most recent El Niño, that warm, pervasive presence, has just ended. They concluded this based on diligently measuring the subtle difference in surface atmospheric pressure in the east-central tropic Pacific, a precise metric known as the Oceanic Niño Index, a pulse of the ocean's breath. Heading for us now, like a gentle, cool breeze on the horizon, is likely La Niña, which is being predicted with a reassuring 71% accuracy. However, initial reports, those first soft whispers of the future, indicate that this upcoming La Niña is going to be a weak event, a gentle presence, rather than a powerful force. And in some ways, for those concerned about the planet's warming embrace, this is a bit of a shame. La Niña's global cooling effect, that subtle lowering of temperatures, would indeed be a good countermeasure, a gentle hand to push back against the ever-increasing global average temperatures we've been seeing lately, a quiet whisper of balance in a warming world. For me, this profound dance of El Niño and La Niña is an excellent example of how patiently studying climate cycles, those intricate rhythms of our Earth, can beautifully help us prepare and gently foster human survival. Not just on this precious world we call home, but potentially on other worlds too, as our gaze turns to the stars. Because one of the most fascinating aspects of the ENSO of this powerful oceanic rhythm is the profound level of insight we gain from it into Earth's incredibly complex climate systems. It reveals the hidden threads, the invisible connections in our planet's vast interwoven tapestry of weather. Understanding the intricate interconnectivity of our own planet's climate, the subtle ways in which all its parts speak to each other, will be absolutely crucial if we ever, in our grand human ambition, wish to settle on other planets, to build new homes among the stars, or even to terraform to gently reshape the very atmospheres of other celestial bodies. If humans eventually undertake the colossal, awe-inspiring task of terraforming Mars, that dusty red world, or Mercury, the sun scorched, or Venus veiled in its dense clouds, or even our own silent moon, or perhaps, with a wilder dream, an exoplanet swirling in some other distant part of the Milky Way galaxy. Our success, our very ability to breathe life into new worlds, will likely depend, with a quiet certainty, on our profound ability to understand the various inputs and feedback loops that so intricately interlink climate systems and biospheres, those delicate webs of life. That day, that distant dream of shaping other worlds, may seem incredibly far off, a whisper from a distant future, but it isn't too early to start dreaming, to allow our imaginations to take flight. For if there's one profound lesson El Niño quietly shows us, it's that the winds of our planet, the very breath of our Earth, work under vast, patient cycles that ebb and flow over the course of years, a constant, graceful dance. However, El Niño, in its powerful elegance, is not the only example of this truth. If earlier in this gentle podcast, you appreciated my small playful reference to the Game of Thrones, that epic saga with the chilling phrase, "Winter is coming," you may perhaps appreciate that this is a reference that keeps on giving its wisdom, echoing through different layers of understanding. In Game of Thrones, the fearsome armies of the Night King, those frozen harbingers of winter from the north, are held at bay, trapped behind a giant ancient wall, a massive barrier of ice and magic. And just like in the captivating TV show, it turns out that here on Earth, in our own tangible reality, there exists a powerful icy force to the north, a formidable winter that is perpetually seeking to overthrow its bounds, to breach its invisible prison, and to rush southward, bringing its chilling embrace to warmer lands. That powerful, encroaching winter is also in a profound parallel kept at bay by a mighty invisible wall, one that allows the civilizations to the south, those living in more temperate climes, to enjoy relatively tranquil conditions, a gentle warmth and peace. And just like in the captivating TV show, that wall sometimes eventually gets breached, leading to a wave of ice that sweeps down and threatens the very lives of all those in its way, a sudden, chilling descent. You might at this point, dear listener, not immediately recognize what I'm gently talking about. Where, you might ask, is this mysterious wall, and what is the icy winter it so diligently protects us? From the answer to the first question, I must confess, is a name that I find particularly cool. With a quiet sense of scientific poetry, it is the polar night jet, and it turns out that the polar vortex, that vast swirling chill it protects us from, is a biting, formidable force not to be underestimated. So what then is this polar vortex, this swirling entity of cold, and how does the polar night jet, with its unseen power, protect us from its icy embrace? For our third Earth cycle, our next quiet step in understanding our planet's breath, it's time to take a deeper, more detailed look at the Earth's atmospheric winds, those invisible rivers that shape our sky. I was perhaps a little misleading earlier in my playful introduction when I spoke of a polar vortex as if there were only one singular entity. In truth, dear listener, there are quite literally two polar vortices, two vast swirling centers of cold, one at each majestic pole of our planet. And even within each of these immense vortices, the complexity deepens. For each vortex comes in two distinct interconnected parts. First, there is a tropospheric polar vortex, a powerful spinning mass of air residing in the section of the atmosphere closest to us known as the troposphere. This layer extends from ground level up to about 10 to 15 kilometers, and remarkably, this is where a vast 75% of the total mass of the atmosphere, the very air that cradles us, gently resides. Above that, in the higher, more ethereal reaches, lies the stratospheric polar vortex, a technically separate weather phenomenon, yet one that holds its own immense size, follows its own seasonal cycle, and exerts its own profound influence on the global climate. Each of these massive cyclones, these swirling giants of air, quietly sits over its respective pole, spinning in harmony with the planet's own rotation, its invisible currents moving with a powerful grace. Within their heart, the wind speeds, can reach an astonishing 240 kilometers per hour, a force to behold. So we might gently ask ourselves, why do these powerful invisible winds, these grand cyclonic dances, truly happen? The very first piece of this intricate puzzle, the fundamental seed from which these vast systems grow, is the subtle yet powerful temperature difference across our planet. Consider for a moment locations like the equator, where the sun's golden sunlight is most concentrated, most direct, like a focused beam of warmth. Here, the air bathed in this intense heat is warmed and begins to rise, ascending gracefully into the sky like a gentle, unseen breath. As it does so, it creates an area of low pressure beneath it, like a gentle void that naturally draws air into it from its surroundings, from the cooler, denser regions beyond. It acts in essence like a giant, silent vacuum cleaner, continuously drawing in the air around it. Meanwhile, at places like the poles, those quiet, icy realms where it is much, much colder, the air chilled and dense contracts and gently falls, descending towards the surface. This creates zones of high-pressure areas where the air molecules packed tightly together want desperately to spread out to escape, like a joyful crowd of schoolchildren suddenly released into a wide open field. So naturally, with these two fundamental forces gracefully at play, the pulling low pressure at the equator and the pushing high pressure at the poles, there is an inherent powerful tendency for air to rush, to flow with purpose from the cold, high-pressure poles towards the warmer, low-pressure equator. It's a constant, fundamental drive, a perpetual quest for balance. Freezing cold winds are in essence constantly trying to escape from the majestic north and south poles, seeking warmer climes, a softer embrace. This model, while beautifully illustrative, is a little simplified, a mere whisper of the full truth. For wind, in its grand complex dance, does not simply travel in one continuous straight line from the pole to the equator. Instead, because air rising from the equator cools and falls much sooner than it reaches the pole, typically around latitude 30 degrees, and conversely, air from the poles warms and rises much sooner than it reaches the equator, to Sanku around latitude 60 degrees, a more intricate pattern emerges. Within each hemisphere, dear listener, there are three distinct cells of air, three vast invisible cylinders within which air gracefully circulates, each playing its unique part in the global ballet of winds. There are the polar cells, the masses of air that hover protectively above the poles, engaged in their perpetual dance of cooling and falling. And there are the Hadley cells, the immense air masses that gently embrace the equator, rising with the warmth and descending as they cool. Both these polar and Hadley cells cycle in the temperature-driven way I just softly described, their movements dictated by the fundamental push and pull of heat and pressure. However, the middle cell, beautifully known as the Ferrel cell, is quite different. It is not in its essence temperature-driven. Instead, like a vast invisible gear, it is subtly dragged along by the rotation of the other two cells, the Hadley and the polar. And in an elegant counter-motion, it rotates in the opposite direction to their flow, a beautiful testament to the intricate interwoven mechanics of our atmosphere. In terms of our northern polar vortex, this intricate dance of cells means that once the cold air from the pole, released from its high-pressure embrace, gently heads south, it is met by warmer wind, traveling with equal determination in the opposite direction. And when two air fronts, two vast invisible armies of air of different temperatures meet, they do not simply mix, do not gently blend into one. Instead, they clash like two grand opposing forces, creating an invisible boundary, a zone of turbulent interaction. So the polar vortex, that mighty swirling entity of cold, finds itself trapped, bounded constantly. Clashing against the warmer winds coming in from all sides, a prisoner of its own cold. Yet there is more at play here, a deeper, more subtle force. If this were on its own, if it were merely a clash of temperatures, the cold air from the north would simply slide underneath the warmer air from the south, not truly being trapped at all, but merely finding a new path. There is, however, A second powerful force at play, an invisible sculptor, that redirects those winds, spinning them into a magnificent perpetual vortex that keeps them circling the poles, their icy embrace confined, rather than allowing them to escape and rush down towards the equator. So we might gently ask ourselves, where does this powerful perpetual spin, this invisible artistic touch that shapes the vortex truly come from? It is, dear listener, due to something beautifully known as the Coriolis force, that elegant, often misunderstood dancer of our rotating planet. Imagine for a fleeting moment a simple flat world, a vast, featureless sheet. In such a simplified realm, cold wind from the poles would simply travel in a straight line towards the equator, and warm wind from the equator would float gracefully over it, ascending towards the poles. A straightforward two-dimensional ballet. But our world, our beautiful Earth, is not a simple flat sheet. It is profoundly a rotating sphere, a magnificent blue marble constantly spinning through the cosmic expanse. You, dear listener, as you sit here quietly absorbing these words, are traveling right now at a speed that varies dramatically depending on your location. If you happen to be at a pole bravely deciding to listen to an astronaut podcast while you were there, your eastward speed would be 0 kilometers per hour. But if you were at the equator, you would be swiftly moving at roughly 600 kilometers per hour, carrying you from the west to the east, an astonishing silent journey. You might not notice this fact in your daily life because everything next to you, all the air, the trees, the buildings is on average, traveling at the same speed in the same direction, caught in the same rotational embrace. But what happens? We might gently ponder if you were to travel from the equator, that place of rapid eastward motion towards one of the poles where the eastward speed gracefully diminishes. The fundamental principle of conservation of momentum, that beautiful law of physics, states that you would still be traveling eastward at the same initial speed as previously, carrying that rotational energy with you. But suddenly, with a subtle shift, the Earth beneath you is not traveling quite so fast to the east. Remember, at the pole, you'd eventually have 0 eastward speed relative to the Earth's rotation, but would simply be rotated slowly in place. If, on the other hand, you somehow manage to keep all your initial eastward momentum from the equator, that powerful initial push, and then travel directly towards the pole, suddenly it will appear, compared to everything else around you, that you are traveling east really, really fast, like a swift bird against a slow-moving cloud. In practice, this means that air that travels up towards a pole from the equator, whether it's towards the North Pole or the South, will not go straight up. Instead, over large distances, over the vast expanse of our rotating world, it will start to curve, to gently deflect towards the east, caught in the invisible embrace of the Coriolis force. This rapidly eastward traveling air, this powerful invisible river, is precisely why you get jet streams, those magnificent swift currents that shape our weather. There are at least 4 of these powerful ribbons of air gracefully straddling the invisible gaps between the Hadley cells, the Ferrel cells, and the polar cells, those vast atmospheric cylinders we spoke of earlier. The subtropical jet stream lies quietly between the first 2, the Hadley and Ferrel cells, and is a little weaker, a gentler whisper of a current. But the jet streams we are most interested in, the ones that play a crucial role in our story, are the polar jet streams. These powerful swirling currents wring the frigid air, that dense, biting cold that develops in the North and South poles, holding it in a delicate, often tumultuous embrace. These ribbons of air, these invisible highways in the sky, circle the globe in an almost continuous path, an unbroken flow, a little underneath the invisible boundary between the troposphere where we live and the stratosphere, the layer above. They are only a few kilometers deep, thin as a whisper, but can be hundreds of kilometers wide, vast and encompassing. And in their very hearts, the wind, the invisible breath of our planet, can travel at an astonishing 400 kilometers per hour, a truly formidable force. As a gentle reminder, winds exceeding 120 kilometers per hour are already entering the strength level of hurricanes, those swirling giants of destruction. The jet stream around the South Pole, that majestic southern ring of air, is in its profound solitude fairly stable, a remarkably consistent barrier. Its powerful winds, moving with an unwavering strength, usually overrule the polar winds that are constantly trying to leave the polar air mass to escape its icy embrace. Instead of breaking free, these nascent polar winds are whipped along with the powerful jet stream, dragged into its mighty current. This relentless capture pulls the entire polar cell, that vast cylinder of cold air, into a massive Antarctica-spanning vortex, a powerful swirling entity of cold that rarely breaks its bounds. At this point, a keen-eyed observer, a mind gently attuned to patterns, might have noticed a subtle flaw in this beautiful model, a quiet question lingering in the air. If conservation of momentum means that air going from the equator towards the pole veers towards the east, then why is it that air traveling from the pole towards the equator doesn't do the exact opposite? After all, it starts with very little eastward momentum, moving into zones that have considerably more momentum comparatively. It should by all rights be quickly left behind, appearing to start spinning to the west as if pushed backwards by the Earth's faster rotation. This observation is indeed true, dear listener. The cold winds, as they begin their journey from the pole, do indeed have much more friction to contend with. As this cold air starts to slide underneath the warm front, that invisible boundary, it then drags along the ground, encountering resistance from the very surface of the Earth. This friction, this subtle drag, seems to slow it down just enough that the countervailing jet stream, that powerful eastward current flowing above, overrules it, maintaining the overall pattern. It's important to quietly note this delicate tension at play, this constant subtle struggle between opposing forces, for this very tension becomes much more important, much more pronounced in the fascinating phenomenon we call the polar night jet. The polar night jet is, in essence, the specific jet stream that gracefully bounds the vortex at the North Pole. More precisely, it bounds the stratospheric polar vortex, that higher, more ethereal swirling mass of cold, diligently keeping it in check during the coldest, darkest part of the year for the North. This is the period of the polar night, a time during the winter months when the sun, our great source of light and warmth, is absent from the sky, entirely never rising above the horizon. This prolonged darkness, this deep absence of solar energy, creates even more freezing temperatures, a profound chilling of the air. Interestingly, this colder climate, this intensified chill, creates a deeper, more pronounced pressure difference between the air around the pole and the air further south. This greater pressure gradient actually strengthens the very forces that create the polar night jet, meaning that during the coldest, darkest part of the year, this freezing, powerful air is usually well contained, held firmly within its invisible walls, a beautiful example of nature's self-regulating mechanisms. However, dear listener, this delicate balance does not always hold true. Like a perfect melody that can sometimes be disturbed by a jarring note, there are subtle yet powerful things that can disrupt a jet stream, altering its graceful intended path. There are certain zones, for instance, such as the invisible boundary between sea and land, where two vastly different surfaces meet, or the majestic presence of a large mountain range, a colossal obstacle rising from the earth that can cause profound disruption to the flow of wind, creating turbulence and eddies. Coastal environments, with their unique interplay of land and water, create their own local winds that can subtly suck in, can gently draw jet streams, pulling them off their usual course, while towering mountains like silent giants physically force an air current to move around them, creating kinks and bends in the flow. Even other powerful weather phenomena, such as El Niño, that great Pacific whisper we just explored, can have a profound impact on the path that a jet stream takes, subtly influencing its journey across the globe. This is because the jet stream, in its essence, is not fixed down, not rigidly anchored to the earth. Rather, it is a delicate balancing point, a sensitive scale poised between a range of opposing forces, constantly tugging and pushing on each other. When it encounters such obstacles, when it runs into these disruptions, it causes it to deviate from its course, to gently swerve from its intended path. And once it starts deviating, once that initial wobble occurs, it will rock back and forth like a string that has begun bouncing no longer in its perfect balance. It shifts, overcorrects itself, then is no longer in balance again, and overcorrects itself yet again, creating vast, sweeping planetary waves that force the polar night jet to meander, to gently wander around the Earth, rather than traveling in a straight, unwavering line. And these great oscillations, these wide, graceful wobbles, can in dramatic moments reach a point where there is a breach, a tear in the invisible wall, and the mighty polar vortex can escape its bounds. The very first sign of this dramatic shift, this subtle crack in the invisible wall, often comes in the form of what is known as a sudden stratospheric warming, or SSW. This remarkable event is most commonly observed in late winter, a surprising burst of warmth in the heart of the cold. An SSW can even represent a time where temperatures in the polar region, that usually frigid realm, rise by as much as 50 degrees Celsius over the course of just a few days, an astonishing rapid transformation. Something profound within the intricate system of the jet stream can be so violently thrown by this sudden warming, so profoundly destabilized, that it leads to the southern moving westerly winds, those currents that normally flow from west to east, overpowering the jet stream, partially or even completely reversing its flow, like a river suddenly deciding to run upstream. No longer contained, no longer held within its powerful boundaries, the Arctic wind, that icy breath now moves inexorably. South meeting warmer and warmer air, pushing faster and faster south in a desperate attempt to balance the gradient, to equalize the pressure. The entire jet stream buckles like a vast invisible ribbon twisting, and suddenly it pivots massively, reorienting itself, traveling down the planet. And in this dramatic shift, regions like Europe and America, usually safely nestled on the warm temperate side of the polar night jet, suddenly find themselves squarely in the chilling domain of the polar vortex. The forces of winter, in their raw, untamed power, have truly arrived. You may not have realized it, dear listener, but one of these powerful jet stream reversals, one of these dramatic shifts, took place just in March 2024, a very recent whisper of this ancient power. It was a significant reversal too, a truly profound shift, with wind speeds flowing so fast in the wrong direction that it was labeled one of the top 6 most extreme reversals on record, a powerful testament to its intensity. However, by a stroke of quiet luck, the polar night jet did not meander much from its usual course in this particular reversal, its powerful spiral remaining relatively confined. This meant we did not see the freezing polar winds reaching far beyond their usual Arctic home, a fortunate outcome. Instead, the swirling winds in their unusual flow sucked up a large amount of ozone from lower latitudes, where it is more abundant, causing a noticeable spike in ozone above the North Pole. Much preferable, we can agree to a devastating ozone hole, a quiet blessing in the midst of a powerful event. The reversal thankfully has already gracefully gone back to normal, the winds returning to their usual direction, having only flowed in the opposite direction for a couple of weeks. All in all, it could have been a lot worse, a more profound and chilling experience for many. In fairness, dear listener, not all of these events, these dramatic shifts in the polar jet stream, are devastating. Not all are harbingers of profound hardship. With sufficient preparation, with a little foresight and a warm coat, you can simply put on some warm clothes, or perhaps try to avoid going outside for the month or so that the polar winds are overhead, allowing their icy breath to pass by. As long as you're ready for the cold, it's not the end of the world, merely a temporary inconvenience, a brief interlude of chill. However, sometimes the outcome can be much more serious, much more profound. In the UK, for example, in the winter of 2009 to 2010, the infamous Big Freeze settled over the land, bringing parts of Scotland to reach astonishingly low temperatures as frigid as 22 degrees Celsius, the coldest in nearly 40 years. This widespread chill brought with it significant transport disruption, grinding travel to a halt event, closures, canceling gatherings and celebrations, and widespread power failures, plunging homes into darkness. Sadly, this powerful weather event, this relentless cold in turn, led to the tragic death of 25 people, a sobering reminder of nature's power. In the U.S., the January-February North American cold wave of 2019 saw a powerful polar vortex move down across much of the country, sweeping southward with its icy embrace, bringing similar devastating outcomes. Some areas in their chilling grip saw temperatures as low as 50 degrees Celsius and almost unimaginable cold, especially if you take into account the wind chill factor from the blustery freezing winds. Snowstorms raged, blanketing the landscape in white, and the cold was so intense that you could get frostbite from being outside in just 10 minutes, a chilling testament to its ferocity. Sadly, another 22 people died during this brutal period, with hundreds more needing treatment for severe frostbite, their bodies wounded by the extreme temperatures. Responsible for this profound suffering was the raging polar vortex unleashed from its usual confines. In time, the imbalances in the global temperatures, those subtle pressure gradients, restore themselves, and the jet stream gracefully returns to its previous position, its invisible walls rebuilt. However, it's worth noting, with a quiet sense of awareness, that some level of jet stream breakdown, some degree of this wall being breached, occurs in the north approximately 6 times every decade, making it a relatively common, albeit powerful occurrence. If you live in the northern hemisphere, dear listener, you will likely see many more of these events over the course of your lifetime, though hopefully not all as powerful or as devastating as these 2 chilling examples. In the south, you are thankfully likely safer from these dramatic shifts. There have only ever been 2 instances in recorded history of the southern polar jet stream, breaking down in the same profound way as the northern one, its powerful grip remaining largely unbroken. It has happened, though, a quiet whisper of possibility, and the intricate mechanisms behind it are not fully understood, still holding their secrets. It's difficult to say with certainty as global temperatures gradually rise, warming our planet inch by gentle inch. What subtle influence this might have on the jet streams, those powerful rivers of air. Some evidence indicates that they are traveling further poleward, on average, year on year, a subtle shift in their position, although this is apparently not unheard of in the planet's long ancient history. There is some more evidence, a quiet whisper of reassurance, that the jet streams have actually strengthened since 2002. If so, we should perhaps be grateful for their strength, provides a crucial barrier. Although unpleasant, the biting cold of the polar vortex when it descends is usually only a passing weather phenomenon, a temporary guest. We see it return north within a month, its icy embrace receding. But if the jet stream, that mighty invisible wall, were to completely go to vanish entirely, the polar vortex would then come down from the north to stay, and we would truly know what it is like to live in Arctic conditions, a world transformed by perpetual winter. The more I've learned about this fascinating subject, the more I've discovered that the winds of our planet, the very breath of our Earth, are this truly captivating weave of interplaying forces and effects. They tug and pull on each other subtly, influencing and counterbalancing, finding perfect fleeting balances and yet constantly shifting in their rhythms and patterns, an endless intricate dance. And yet, it does so practically, invisibly, silently, in plain sight. So much profound activity is going on, so many grand interactions are unfolding, that we simply do not see down here on the ground, living our daily lives. Just because air in its very essence is, well, air invisible, intangible, seemingly empty. And yet, through this quiet exploration, I have learned its immense importance. The polar night jet is not just wind with a cool name. It is a bastion of protection, an invisible wall against the frozen wind, a guardian we never perceive. It really makes you think of the incredible majesty of the world around us, the profound unseen forces that are constantly at work protecting us, shaping our reality that we simply do not see until we quiet our minds and truly begin to look. Milankovitch cycles and the rhythms in our wind, those grand invisible choreographers of our planet, can indeed have a slow yet incredibly powerful influence on the climate of the Earth. They unfold over vast timescales, their subtle whispers shaping continents and guiding the pulse of ice ages. But they are not by any means the only patterns and rhythms shaping the lives of the myriad organisms on this planet, from the smallest blade of grass to the most majestic whale. For our fourth Earth cycle, let us now gently turn our gaze to a rhythm which, rather than originating in the gravitational push and pull between planets and our sun or the gusting invisible currents of trade winds, instead lies in the very beating heart of magma beneath the Earth's surface. Imagine, if you will, a metaphorical giant hourglass, immense beyond comprehension, lying deep within our planet, hidden from our sight. This hourglass, unlike any we know, slowly runs out its sands, its timeless grains, marking the passage of epochs, not minutes. And then, when it has run its course, when its sands have settled it quietly, waits ready for a dramatic reversal, a profound flipping of its very being. And when those reversals, those grand unseen transformations finally come, the results are devastating, not to the land itself, but to the very magnetic fields that encircle us, that cradle our planet in a protective embrace, keeping us safe from the harsh breath of space. And this, dear listener, can be a very big, very real problem indeed. It may surprise you, as you settle into this thought, to learn this profound truth. Whispered from the depths of our Earth, the time will come in the vast, patient unfolding of planetary history, when the North and South poles, those comforting, unwavering beacons on our maps, will quietly swap places. Imagine that for a moment, the very orientation of our compasses, flipping the magnetic north, becoming the magnetic south. Humanity in its future forms will need to be ready, profoundly prepared for the upheaval to our civilization that could gracefully follow such a monumental shift. When you think about the North Pole, that steadfast point of orientation, you don't expect it to go anywhere, do you? And you certainly don't expect it to magically change places with the South Pole. That would just feel fundamentally wrong, wouldn't it? Our familiar magnetic compasses would all point the wrong way, suddenly leading us astray. We'd need to update all our maps to redraw the very lines of our navigation. Birds, those wondrous navigators of the sky, would probably be horribly confused, their innate sense of direction suddenly scrambled. And yet, dear listener, although they sound like something conjured from the thrilling pages of science fiction, geomagnetic reversals like this are profoundly real. They've happened before countless times in our planet's deep past. And the patient, invisible process behind it, the quiet unfolding of these grand shifts, might be a lot more dangerous, a lot more impactful than you'd initially think. To be clear, it's not the reversals themselves that are potentially dangerous, not the simple flipping of the poles that poses the greatest threat. No, it's the quiet, often prolonged buildup during those times that holds the true concern. During these periods of grand transition, the Earth's magnetic field, that invisible ethereal shield around our planet that faithfully keeps us safe from deadly solar radiation, that harsh, energetic breath from our sun, will dramatically drop. Its strength, its protective embrace, could fall to as low as 10% of its current robust power. This profound weakening, this thinning of our shield, has led one group of scientists in 2021 to predict, with quiet apprehension, climate shifts and even mass extinctions, vast disappearances of life from the Earth. Others describe a more immediate technological upheaval. Satellites being tragically destroyed, their delicate circuits fried by unfiltered radiation, electrical grids going offline, plunging vast regions into darkness and deadly radiation, raining down on us for hundreds or even thousands of years, a silent, pervasive threat. This, dear listener, is indeed troubling. especially when we consider that based on the Earth's past rhythms, we are a couple of 100,000 years overdue for our next geomagnetic reversal, as if the planet's internal clock has paused. And based on subtle fluctuations in the Earth's magnetic field that patient scientists are detecting right now, like faint tremors deep within the Earth, the buildup to a geomagnetic reversal may even have gently begun already. Which naturally begs the profound question, should we be worried? Let us begin by quietly trying to understand where the Earth's magnetic field, this invisible guardian, truly comes from in the first place. It's not a given, you see, that our planet would possess such a powerful protective magnetic field. Look at our two planetary neighbors flanking us in the solar system: Mars with its dusty red surface, and Venus shrouded in its thick, toxic clouds. Neither of them possesses a magnetic field, and yet our Earth does. And this is profoundly fortunate, a quiet blessing. For without one, there is a very real, almost certain chance that life in all its wondrous forms would not have been able to arise here in the first place. Thanks to the protective cocoon of this field, this invisible ethereal shield. Deadly solar radiation, the harsh energetic particles streaming from the sun, is gently deflected away from the planet's surface, harmlessly turned aside. This allows life in all its delicate complexity to flourish, to thrive free from the constant bombardment of radiation that would otherwise break down our very DNA, causing mutations and devastating cancers. Scientists are still patiently trying to figure out all the intricate particulars of why certain planets are blessed with magnetic fields and certain others are not, the subtle hidden conditions that allow this phenomenon to arise. But the current leading theory, the most compelling whisper of understanding, is that the Earth's core, the very heart of our planet, acts as a giant dynamo. This concept draws from a fundamental principle of physics, a beautiful interplay of forces. You can use electrical fields to create magnetic ones, and vice versa. This very principle, this elegant exchange, is what powers our familiar power plants, those humming giants that provide us with electricity. There, moving a magnet through a coil of wires causes an electrical current to start to flow, to surge, with purpose, as that changing magnetic field exerts a force on the electrons present within the wires. But similarly, and in reverse, the motion of electrons, those tiny charged dancers, creates a magnetic field to form in perpendicular circles around the direction of their motion, in beautiful accordance with Faraday's law of induction. But the way this elegant principle applies to the Earth's core, that hidden fiery heart, is a delicate, wonderfully complicated process. To begin with, our core needs to be at least partially liquid, a swirling conductive ocean, which, fortunately, is wonderfully true. Above the solid inner core that lies at the very heart of our planet, like a diamond nestled deep within, is a liquid outer core. Here, the immense pressure isn't quite high enough to keep things in a solid state, allowing the material to flow freely. It's incredibly hot in the outer core, though a staggering 6,000 degrees Celsius at its warmest point, a temperature so intensely fiery that it rivals the very surface temperature of the sun. This extreme heat, when combined with the slightly lower pressure compared to the inner core, is more than enough to keep the iron and nickel that makes it up in a constantly flowing, swirling state down there. The temperature, in a gentle, predictable descent, drops as you move away from the very center of the Earth, moving outwards towards the crust. This subtle temperature gradient, this gradual cooling, is what gets the circulation going. What sets the dynamo in motion? Hot conductive material from the warmer, deeper regions of the outer core, infused with energy, rises gracefully. Then, as it ascends, it cools ever so slightly, and then gently falls again, descending back towards the warmer depths. This continuous cycle of rising, cooling, and falling creates vast, intricate loops and currents of flowing material, a slow, majestic convection. And as this conductive molten material flows, as these loops and currents swirl, our electrical field begins its silent generation, a subtle hum of energy. But if there are many of these flowing loops, these intricate currents, which in theory there would be, Why does Earth, our vast, complex home, only seem to have one North Pole and one South Pole? Those distinct magnetic beacons. Surely the created magnetic fields, born from these myriad loops, would be all over the place, a chaotic tangle, wouldn't they? Well, dear listener, there is thought to be an extra force at play, a subtle, powerful choreographer that takes all these individual fields and elegantly unifies them patiently, pointing them in the same grand direction. This unifying force is thought to be none other than the Coriolis effect, once again that graceful dancer of our rotating planet. Dynamo theory, the leading scientific whisper of understanding, states that the Coriolis effect, through the immense scale of Earth's spin, causes these vast flows of molten iron to not simply rise and fall as straight lines, but rather to spiral, to elegantly twist as they move like colossal unseen springs. The gentle, relentless spinning of the Earth causes them to be gently spun in turn, creating these giant, swirling springs of molten metal. As each segment of each of these immense springs is in its own small way creating a magnetic field in a circle around it. The net result, the profound culmination, is that the inside of these vast spiraling springs creates a solid unified field. This grand coherent field all moves in the same general direction upwards towards one pole, while the outside brings that very same magnetic field looping gracefully back down again, returning into the bottom of the coil, completing the circuit. In short, it elegantly creates the well-known magnetic dipole, the distinct north and south poles that we observe today, a testament to the elegant physics at play deep within our Earth. However, dear listener, if there's one profound truth that you should gently take away from this exploration, it's that this entire process, this beautiful, intricate generation of our magnetic field, is remarkably precarious. It is, in its very essence, based on a vast, churning sea of liquid iron, essentially just slushing around, moving and flowing in complex ways, and such a fluid dynamic system is by its very nature not very consistent, not perfectly rigid in its movements. Our magnetic field, this vital shield, thus has little fluctuations and wobbles all the time, subtle tremors in its powerful embrace. We see this in different ways in various manifestations, but a big noticeable one is that our North Pole, our magnetic north, is constantly moving gently, shifting its location across the Arctic landscape. Ever since patient scientists began keeping diligent track of it in 1831, the North Pole has gradually shifted about an hour 100 kilometers, a significant journey, leaving its original location in the frozen wilderness of Canada and slowly moving up towards the vast icy plains of Siberia. Its rate of motion, its quiet journey, is also remarkably increasing, going from a leisurely 16 kilometers a year to a much swifter pace of roughly 55 kilometers a year, a big surprising jump in its speed. This swift, accelerating journey of the magnetic North Pole might at first glance still be akin to just the momentary wobbles of a spinning top, a gentle deviation from its perfect axis. Yes, it deviates somewhat. It sways slightly, but it always remains roughly upright, maintaining its general orientation. That you might think is a far cry from a complete reversal, a profound flipping of its entire being. However, dear listener, scientists are profoundly certain that such grand reversals have indeed happened before countless times in our planet's deep past. They even have a specific number whispered from the geological record 1883 times in the last 83 million years, a staggering testament to the dynamic nature of our Earth. How do they know, you might gently ask? The answer lies patiently locked in our Earth's very surface, etched into ancient rocks and the silent wisdom of iron. When magma, that fiery molten rock from the Earth's mantle, gently erupts from beneath the surface, it can contain small microscopic amounts of iron, those tiny magnetic particles. As these minute iron particles can move freely, can orient themselves without resistance in the molten magma, they tend to align themselves precisely in the direction of the Earth's magnetic field at that very moment, like tiny compass needles frozen in time. Then, as the magma cools and solidifies into rock, these tiny iron particles are permanently locked in place, preserving a fossil record of the Earth's magnetic direction at that specific time. However, scientists with their keen observant eyes noticed something remarkable in different layers of geological history. There were distinct layers of rock where the iron was pointing one way, a clear indication of the magnetic field's orientation. And then in other layers, representing different epochs, the iron was pointing in the complete reverse direction, a startling contradiction. Their profound explanation, their elegant conclusion was that the entire pole of the planet, its magnetic orientation, had in fact flipped a grand unseen reversal. On average, these grand flips, these profound reversals of Earth's magnetic field, seem to happen every 450,000 years, a patient, predictable rhythm in the vast geological clock. Although with a subtle unpredictability, the last few have only had gaps of about 300,000 years between them, suggesting a slight acceleration. Comparatively, it has now been a profound 700 to 50,000 years since the last complete reversal, a significant stretch of time. You might, with a gentle sense of apprehension, think that we are overdue for one that the Earth's clock is running behind, and indeed, some have made that very claim. However, scientists in their deeper wisdom have found that there's little rhyme or reason, little predictable pattern to the precise timing of these flips. They are more like sudden, unpredictable turns in a long winding story. One of the longest gaps between flips, a vast stretch of magnetic stability, took place in the Cretaceous period, that ancient era of dinosaurs, and it lasted for a staggering 40 million years, a truly immense period of time. The record holder, a period known as the Kaiman Reverse Superchron, stretched from 312 to 262 million years ago, a colossal 50 million years, with no reversal at all, a quiet testament to the Earth's unpredictable nature. Scientists are still patiently trying to understand what precisely causes these grand flips, what subtle force triggers such a monumental event. However, the current leading theory, the most compelling whisper of understanding, is that something, perhaps some intricate interplay between the mantle, that vast layer of solid rock, and the liquid outer core, that churning sea of molten iron, causes a profound fluctuation in the core's spinning motion. This subtle disruption unsettles the elegant spiraling shapes of the core's flow, those colossal unseen springs we spoke of causing them to break down, to lose their coherent form. When this occurs, the magnetic field of the Earth, that invisible guardian, stops being unified, stops acting as a single coherent shield. Instead, it generally becomes a sprawling mess, a chaotic tangle of magnetic lines, fighting against itself, its power diminished. Several poles, rather than just two, might temporarily arise during this period of shifting magnetic confusion, like scattered flickering lights. While in time, things gradually settle down, and the spirals reassert themselves, regaining their powerful coherent form, it seems random, purely by chance, as to which way they will do this. This means about half the time, our magnetic North Pole, after its period of chaos, reappears over the geographical south, a complete reversal of its prior orientation. This reasserting, this patient rebuilding of the magnetic field, can take a long, slow time, anywhere from 1,000 to 10,000 years, to fully complete a vast stretch for humanity. All right, but would that really be the end of the world, dear listener? Why does this profound unseen shift in our planet's magnetic embrace truly matter? Well, during that prolonged period, before the poles reassert themselves, before the magnetic field fully regains its strength and coherence, our Earth's magnetic field, that vital protective shield, drops dramatically. Its power can fall to as low as 10% of its current robust strength, like a vast invisible membrane becoming dangerously thin. In theory, this profound weakening could leave us much more vulnerable to all the solar radiation, the harsh, energetic breath that space constantly throws at us, a silent, unseen bombardment. We could see auroras, those beautiful dancing lights of the sky, reaching much further south during that time, painting the night with their ethereal glow in unexpected places. Skin cancer rates, a sobering thought, would likely increase as more harmful radiation reaches the surface. Our precious satellites, those silent eyes and ears orbiting our planet, would find themselves with not enough shielding their delicate circuits exposed. This increased radiation would fry their sensitive electronics, causing them to malfunction, to shut down, and potentially even to slowly fall from orbit, their silent vigil ending. Our electrical grid, the very backbone of our modern civilization, would be much more vulnerable to solar storms, those sudden powerful surges of energy from the sun, which could lead to large segments of the Earth's population being plunged into darkness without power. With no electricity or satellite communication, it would be a devastating blow to our global civilization, a profound disruption to the very fabric of our lives. It could, some whisper with quiet apprehension, be even worse than that. A research team from the University of New South Wales in Sydney, with their diligent curiosity, even linked one of the most recent weakenings of the magnetic field, an event known as the Lachamp event, a temporary, relatively brief 800-year wobble, rather than a full flip to megafaunal mass extinctions in Australia. This included the tragic deaths of giant Australian wombats, huge ancient creatures, and Procoptodon goliath, magnificent giant kangaroos, vast losses of life. Temporary wobbles like this, these shorter, less complete shifts in the magnetic field, are known as geomagnetic excursions rather than full reversals, and they happen over much shorter timeframes, their transitions unfolding more rapidly. Their transition periods, in fact, can last as little as 200 years rather than 10,000, which can be much more difficult for species to adapt to their evolutionary clocks ticking too slowly. In their 2021 study, these researchers argued that there was a spike in atmospheric radiocarbon levels, a clear fingerprint etched in the air, caused by the profound collapse of the Earth's magnetic field. This, they suggested, indicated climate shifts that could have, in turn, led to these extinctions. The timing, they noted, lines up uncomfortably, a chilling coincidence. But how real, how profound are these risks truly? Honestly, dear listener, it's a mixed bag, a blend of concern and quiet reassurance, a point in our favor. A gentle whisper of hope is that other than this recent study, there is no strong indication, no clear evidence from the vast geological record that magnetic field reversals have ever coincided with mass extinction events on a global scale. It seems in the long patient history of Earth that many reversals, countless flips of its magnetic embrace, have come and gone without profoundly affecting animal or plant life at all, leaving the biosphere largely untouched. And even in this particular study about the Australian megafauna, such mass extinctions seem to have been limited in scope, confined to specific regions. There is no claim from the researchers that this was a global phenomenon, a tragedy encompassing the entire planet. Other parts of the world, it appears, remained unaffected, continuing their slow dance of life even during the Lachamp event, that temporary magnetic wobble. It seems that a perfect storm might have been in play, a unique confluence of conditions where specific vulnerabilities over Australia left it more susceptible, more vulnerable to solar radiation at that particular time. In terms of our global society, our intricately connected human world, it's worth quietly noting that these magnetic changes, profound as they are, would unfold over many lifetimes to complete even at their fastest pace. This would be slow enough, a gentle enough progression that we could, as a resilient species, gradually come to terms with our new reality, to adapt to the shifting landscape of magnetic protection. If our satellites, those delicate eyes and ears in orbit, don't have enough shielding, we would have ample time to design and build new ones that were better protected, stronger against the increased radiation. If solar radiation, that silent threat, becomes a larger risk to our skin, we could remain indoors, more seeking shelter from its harsher embrace. Sun cream might become more powerful, more effective to mitigate the dangers of cancers, if not remove them entirely. And according to NASA, with their profound understanding of space, even if our fields were to significantly weaken, it's not as if we would be left without any protection at all. Our atmosphere itself, that beautiful blue blanket around us, can effectively catch radiation, absorbing its harmful energy. This means that we would remain safe from solar winds and cosmic radiation, at least to some reassuring degree. It would take far longer than 10,000 years for our atmosphere's precious ozone, that vital protective layer, to be completely stripped away, a comfort in the face of such a grand timescale. But I would be surprised, dear listener, if there wasn't at least some turmoil, at least some period of adjustment and challenge, while we as a global society gracefully adjusted to living under a reduced magnetic field, a thinned protective shield. Big changes to how a society operates, to its very rhythms and routines, are always painful, always challenging, requiring deep adaptation. And this isn't entirely hypothetical, a mere whisper of a distant future. Did you know that the Earth's magnetic field has been steadily weakening for the last 200 years? A quiet, measurable decline. It would take another 4 or 300 years for it to vanish completely at its current rate. So there's plenty of time, a vast expanse, for it to stop its current downward trend, for its strength to recover. And there's no inherent reason to think this isn't just a temporary wobble, a brief dip, rather than a harbinger of a full reversal. But on top of that, there is also the South Atlantic anomaly, to consider a specific section of the Earth's magnetic field that is already showing signs of significant weakening, a thin patch in our shield. This anomaly covers most of the space around South America and the neighboring ocean, a vast region where the shield is already compromised. This zone might not directly influence life on the ground, but it is dangerous enough that it has fried satellites and threatened astronauts, those brave explorers of space. The Hubble telescope, for example, has to dutifully turn itself off every time it flies through it, protecting its delicate instruments. Imagine that, but across the entire globe. That's what we might expect, what we might quietly brace for while the poles are reversing. Concerningly, the South Atlantic anomaly has been growing continuously since we started keeping track of it, expanding its reach, possibly suggesting the subtle approach of either another geomagnetic wobble like the Lachamp event, or even that a full-blown reversal is already gracefully upon us, its silent, unseen transformation underway. If it happens, if this grand reversal unfolds, it won't likely be something that ends civilization as we know it, a catastrophic collapse. But if the study about Australian megafauna, that whisper from the past, is correct, it isn't going to be without profound impact either. Species could die, their ancient lines coming to an end. Humans will have to accommodate a very different, more hazardous space environment, our invisible shield thinned. It's interesting to learn about geomagnetic reversals and their potential impacts on the planet, these grand unseen dances within our Earth. But while we are not likely to see one happen in our lifetimes, in our brief human span, for the generations of humanity after us, for those who will walk this Earth in the distant future, this might turn out to be a lot less hypothetical, a lot more tangible. They might be seeing it firsthand, a quiet drama unfolding before their very eyes. Given that this collapse has not occurred yet, and our magnetic field remains relatively healthy, a vibrant shield around us, you might think that solar weather, the constant breath and exhalation of our sun, does not have very much influence on life on Earth. Perhaps you might muse its only real impact comes from the sun's relative position to the Earth, as we've explored with the grand Milankovitch cycles. However, dear listener, you would be wonderfully wrong in that gentle assumption. What if I were to tell you, with a soft whisper of surprise, that our neighboring star itself, that immense ball of fire in our sky, could subtly yet profoundly affect your entire life in ways you might never have imagined? You might for a fleeting moment think that I was suddenly taking a sharp turn away from the quiet, patient world of astronomy and drifting into the more ethereal, often mysterious realm of astrology. Don't worry, dear listener, I am not. While there are many beautiful souls in the world who believe with deep conviction that you can learn profound things about your future, about your destiny, by patiently studying the position of stars and planets, tracing their paths across the night sky. It's not a position I tend to take on this channel. My curiosity, my gentle fascination, is more deeply rooted in the sheer incredible beauty of space itself and the intricate, elegant mechanisms that explain why it is the way it is, why the cosmos unfolds in such a magnificent fashion. But sometimes, just sometimes, there is a grain of truth, a tiny luminous seed of scientific understanding, hidden behind even the most surprising of stories, the most unexpected of whispers. So allow me for a brief playful moment to put on my prophesying hat, not to foretell your doom, but to share a scientific musing. While I am certainly no writer of horoscopes, no teller of individual fates, I will predict with a quiet confidence based on the current observed state of the sun that as we gently get closer to 2025 a year, just on the horizon, you dear listener might be more likely to experience slightly less robust health encounter, less reliable technology, see warmer weather with fewer clouds drifting across the sky, and possibly, with a truly surprising twist, could be influenced in other even more unexpected ways. How do I know, you might ask with a gentle curiosity? Because it turns out the sun, that giant fiery heart in our sky, is not just the place where we draw our fundamental energy, the source of all life. Science, with its patient, ever-unfolding discoveries, is starting to show that its profound, rhythmic 11-year cycles might just in their subtle, unseen way be the very metronome, the steady guiding beat, measuring out how life on our planet ticks in its endless rhythm. Our fifth stop, then, in our quiet investigation of Earth cycles takes us off the Earth entirely to the radiant heart of our solar system. I intend, with gentle persuasion, to show you exactly how the cycles of the sun are already influencing the course of your life in ways both seen and unseen. It comes as no great surprise, surely, that the sun, that immense life-giving orb, is profoundly influential to life on Earth. After all, in many profound respects, it is life's very origin, the fundamental spark that set everything into motion. Life on Earth needs energy to function, to grow, to thrive, to simply be. And the sun, with its endless generosity, constantly provides that energy. It offers light for plants, those patient producers, which in turn provide sustenance for herbivores, those gentle grazers. And those herbivores, in their turn, nourish carnivores, those fierce hunters, all the way up the vast, intricate food chain, a continuous flow of energy. It's hard indeed to find anything on Earth that could truly live, that could truly breathe and thrive without the constant, unwavering presence of our sun, its golden embrace. But beyond this magnificent gift of life-sustaining energy, it's easy to think of the sun as fairly static, a constant, unchanging beacon in the sky. We see it rise and fall each day, painting our mornings and evenings with light, but we rarely notice it undergoing any sort of profound visible change, assuming it to be a steady, unchanging furnace. This, however, dear listener, is a subtle illusion, a trick of perception. The sun, in its majestic power, changes all the time, a constant, churning cauldron of activity. As science has slowly advanced, as our tools of observation have grown more sophisticated, and as we've been able to devise ingenious ways to shield out the worst of the sun's blinding glare, it became possible to patiently study the sun's surface with greater detail. As early as 1610, the first whispers of its true nature became clear. It became evident that the sun was not a placid orb, but a boiling, shifting sea of barely restrained plasma, a dynamic, turbulent ocean of superheated matter. And remarkably, this plasma frequently wasn't restrained, despite the immense, intense gravitational force holding it all together, pulling it inwards. The powerful nuclear reactions taking place deep within its core, reaching an astonishing 15 million degrees Celsius in its very center, are so incredibly hot that the plasma bubbles and bursts on its surface erupting into brilliant solar flares that blaze outwards in all directions, like colossal unseen fireworks. Sunspots. Those mysterious dark patches that appear on the sun's surface are, in fact, regions filled with intensely strong magnetic fields, like vast, swirling cosmic magnets. These sunspots can range dramatically in size from a mere 1/600 kilometers across a seemingly small dot to a colossal 160,000 kilometers across, dwarfing our entire Earth. They patiently drift across the sun's face and then vanish following their own mysterious rhythms. And even more dramatically, coronal mass ejections, or CMEs, immense clouds of superheated plasma, explode violently out of the sun's corona, the atmospheric zone above the sun that is strangely a bewildering 200 times hotter than its surface, defying our intuitive understanding of heat. It's hard indeed to find a place in the vastness of the solar system that is as dynamically active, as furiously alive as our sun. What many people do not realize, dear listener, is that this furious activity, this constant churning and bursting of our sun, waxes and wanes like a great unseen tide. The sun operates on a profound, rhythmic 11-year cycle that alternates between a period of low activity, a quiet hum, known as the solar minimum, to a much higher, more furious level, a roaring crescendo, known as the solar maximum, and then, with graceful predictability, it recedes back again to the minimum. Sunspots, those dark magnetic eyes, solar flares, those brilliant flashes and CMEs, those vast explosions of plasma all become dramatically more common, more frequent, during the solar maximum. You are in fact an astonishing 50 times more likely to witness a solar flare, a burst of cosmic energy during solar maximum, compared to the sun's minimum. And large CMEs, those immense clouds of plasma, go from happening perhaps once every few days to multiple times in a single day during the peak of the solar maximum, a truly intense period of activity. This particular rhythm, this 11-year cycle of waxing and waning solar activity, is known as the Schwabe cycle. Interestingly, and perhaps even more profoundly, this Schwabe cycle represents one half of a larger, grander cycle, beautifully known as the Hale cycle. The Hale cycle maps the patient, powerful changes in the sun's magnetic polarity. Once every Schwabe cycle, every 11 years, the sun's magnetic north pole and south poles, those colossal magnetic beacons, quietly swap places, a profound reversal of its fundamental orientation. Then, when another Schwabe cycle gracefully unfolds, the poles swap back again, returning to their original positions. Tick, tick, tick goes the cosmic clock. This constant rising and falling of solar energy levels, this immense ebb and flow, silently thrums through our entire planetary system, rising and falling, like a vast unseen heartbeat, pulsing with an ancient rhythm. And surprisingly beautifully, even though we cannot visibly perceive it, we here on Earth, in our own small corner of the cosmos, move to its rhythmic beat, our lives subtly influenced by its distant pulse. We don't truly understand, with full certainty, why the sun in its magnificent power goes through this specific 11-year cycle. It is clearly undeniably related to the intricate magnetic processes that exist within the sun itself, those vast swirling currents of plasma that generate its powerful fields. Yet, although we have patiently observed these cycles in action for the last 200 years, meticulously recording their every pulse, and have even seen compelling evidence of their profound influence on the Earth over the last 10,000 years, etched into ancient records, we are still no closer to figuring out why the sun cycle has a length of that particular time period. Why 11 years rather than any other duration? What fundamental force, what cosmic drummer truly drives it? Lacking any other obvious compelling answer, some curious scientists have, with a gentle sense of speculation, tried to connect the orbital lengths of Jupiter, that colossal giant of our solar system, which also has an orbital period of approximately 11 years to this solar cycle length. But this could easily be a beautiful coincidence, a harmonious alignment that holds no deeper meaning. Although Jupiter, with its immense mass, represents 2.5 times the combined mass of all the other planets in the solar system, exerting a profound gravitational pull on the Sun, its orbit alone cannot fully explain the subtle, seemingly random variations that the Sun cycle undergoes its unpredictable fluctuations. Much of what truly goes on within the Sun, that fiery, mysterious heart, remains a profound mystery to us, a secret whispered in its depths. But its profound influence on Earth, that is a story much easier to see, much clearer to comprehend. It all begins, dear listener, with the silent, vast expanse of space around us. Space, in its increasing importance, is becoming more and more vital to modern civilization, serving as the invisible backbone for communication, navigation, and observation. So it shouldn't be surprising that CMEs, those immense explosions of plasma and solar storms, those powerful surges of energy streaming from the Sun when they occur more regularly, would have a profound impact on the delicate technology we have carefully placed up there, orbiting our planet. Patient scientists, with their diligent observations, are able to predict the arrival of a solar storm, a powerful wave of charged particles known as a geomagnetic storm, by the time it reaches Earth. They can do this days or even weeks in advance, a remarkable feat of cosmic foresight. This precious lead time allows astronauts, those brave explorers in orbit, to go into safe shelters, to retreat into protected havens, to hide themselves from harmful rises in radiation levels, a silent, invisible threat. And it also allows the delicate hardware on satellites, those intricate machines circling our planet, to be carefully powered down, put into a safe, dormant state, to prevent that precious hardware from being fried, from being irrevocably damaged by the sudden surge of energy. This, you see, is incredibly important. For solar radiation, that unseen force can cause unexpected dangerous electrical currents to form in wiring overloading systems that haven't gracefully gone into a safe standby mode, leading to costly and disruptive failures. But there's another, perhaps, less obvious aspect to geomagnetic storms, one you might not expect. All of that radiation, all that powerful energy, has a subtle yet profound impact on the atmosphere itself. It warms it ever so slightly, a gentle caress of heat. And as the atmosphere warms, it expands, pushing outwards like a soft, invisible balloon inflating. This subtle expansion has a direct impact on our satellites in space, particularly those in low Earth orbit. In the vast, almost empty vacuum of space, it's often said that there is no drag, that objects can orbit practically forever without slowing down. Well, this isn't entirely true, and satellites in low Earth orbit do occasionally, about 4 times a year, need to expand precious fuel to gently correct their orbits, to nudge themselves back onto their proper path, as there is still a tiny, almost imperceptible amount of atmosphere up there creating a faint drag. But when a geomagnetic storm occurs and the atmosphere blossoms upwards, expanding its reach, low Earth orbit satellites suddenly find themselves experiencing much greater friction. They have to maneuver every 2 to 3 weeks, spending valuable fuel to keep from falling from orbit due to the sudden increased drag. And even this constant maneuvering isn't always enough to save them. In 1989, there was a geomagnetic storm so powerful, so intense, that it tragically knocked NASA's Solar Maximum Mission satellite right out of the sky, sending it spiraling back to Earth. Ironically, the mission in its dedication had been studying solar flares, the very phenomena that caused its demise. This, dear listener, is not an isolated incident, a mere anomaly. No, NORAD, the Northern American Aerospace Defense Command, a diligent guardian of our orbital space, has to meticulously relocate hundreds of satellites after each significant geomagnetic storm, as they have been knocked out of their old orbits, their careful paths disrupted. Radiation can also subtly influence our ionosphere, that charged layer of our upper atmosphere, filling it with charged plasma. This can have a slight lensing effect on your GPS systems, those helpful guides that pinpoint your location, subtly reducing their accuracy from within a meter to over 10 meters, a noticeable drift. So the next time you glance at Google Maps and it mysteriously thinks you might be a street across from where you actually are, a powerful geomagnetic storm emanating from our distant sun might just be to blame. Power grids, those intricate networks that deliver electricity to our homes, brace themselves every 11 years for the significant uptake in these current-inducing events, preparing to keep themselves from being overloaded from plunging vast regions into darkness. Amateur radio enthusiasts and airline pilots, those who rely on invisible radio waves for communication, find their high-frequency radio range dropping significantly as radio waves get deflected or even completely blocked by the more powerfully charged ionosphere. Although for such enthusiasts, this can sometimes have an unexpected delightful side effect by cleverly bouncing signals off the charged ionosphere. Radio signals can sometimes be increased and quite significantly amplified in their reach, kind of like how skipping a pebble across the water can sometimes increase its range, making it travel further than expected. Still, for the most part, as I gently predicted in my small horoscope at the beginning of our journey, this all adds up to some less reliable technology, a subtle inconvenience in our modern interconnected world. The fact that the next solar maximum, that peak of solar activity, is expected to arrive soon in 2025 makes me quite confident in my gentle prophesying. Yet, dear listener, there are some bright sides to this cosmic dance. As space weather becomes more turbulent, more active parts of the world, such as our northern neighbor Canada, see a beautiful noticeable rise in the number of auroras, those ethereal dancing lights that paint the night sky with mesmerizing colors. Aurora chasers, those dedicated souls who seek out these celestial displays, report rises in sightings from just a few times a year to as many as twice a month during the most energetic parts of the sun's 11-year cycle. A truly magnificent display of nature's power. So much for the sun's profound influence on space and our technology. You might at this point think that that's the end of it, that the sun cycle might influence machinery and signals. But it's not going to make much difference on anything alive, on any living creature. Right. If you think that, dear listener, you'd be beautifully, subtly wrong. It's not for nothing, you see, that the rest of my horoscope, that gentle prediction, mentioned poorer health. There's growing fascinating evidence that the sun cycles, those profound rhythmic pulses, can even influence ecosystems and species themselves, including, perhaps surprisingly, U.S. humans. Some of this influence is incidental, a subtle ripple effect. When the Schwabe cycle is at the solar minimum, that quiet, less active phase, the sun exerts less pressure through its solar winds, those gentle streams of particles. This means, ironically, that we actually get less protection from our heliosphere, that vast bubble-like shield created by the sun's outflow from cosmic radiation, those highly energetic particles from deep space. This form of radiation is incredibly energetic, but fortunately, it rarely makes it all the way through our dense atmosphere to the ground. For that very reason, as it's likely to be absorbed or deflected by a passing air molecule. But simply reaching the atmosphere, reaching that protective layer, is all that's needed to produce a subtle yet profound effect. There is a theory, a quiet whisper of scientific possibility, although still far from certain, that this extra radiation, this subtle cosmic bombardment, could be creating nucleation sites in the atmosphere, tiny points around which water vapor can condense. This, in turn, could lead to the formation of extra clouds, subtly influencing our weather patterns, a direct link between the distant cosmos and the skies above us. Even if that precise mechanism isn't occurring during solar maximum, that peak of solar activity, the space weather hitting our atmosphere can raise global temperature slightly, ever so gently, as my horoscope at the beginning predicted a subtle warming of the weather. Not by much, it should be said, less than half a degree Celsius, and the temperature always eventually returns to where it started, a gentle balancing act. But it's enough subtle as it is that it's noticeable to species paying close attention to temperature, for instance, when deciding where to start their mating season. A crucial biological rhythm. Studies of birds. Those sensitive creatures have beautifully shown that on warmer years, They tend to lay eggs earlier, adjusting their delicate life cycles to the subtle shift in temperature. Curiously, a study published in 2009 by patient researchers in the Netherlands went as far as to show that the laying times of blue tits, those small vibrant birds, were also affected by the number of sunspots occurring, those dark magnetic eyes on the sun's surface. This was a finding that even the researchers themselves found hard to explain, a profound mystery defying easy answers. It's not like birds can look at the sun to count how many sunspots there are, their eyes not equipped for such a task. Nevertheless, a link, a subtle unseen connection, seems to exist according to the 5 nesting groups that were diligently looked at. This isn't something that affects just blue tits, those charming little birds, or even species like homing pigeons, those remarkable navigators that are known to be particularly sensitive to magnetic fluctuations, who fly different routes depending on what time in the 11-year cycle it is. No, dear listener, I'm talking about the last unmentioned point in my horoscope, that gentle prediction, bad health. There are numerous studies, patient explorations by curious minds on how solar cycles, those immense rhythmic pulses, might subtly influence human health. In 2011, a study spanning 2 decades looking at nearly 1/3 of all women in Holland uncovered a subtle, yet statistically significant peak in 6 cervical pathologies that consistently took place just after solar maximum, when the sun's powerful radiation was hitting hardest, its energy most intense. The study also, in its thoroughness, checked 1 man during the same period, which admittedly is a much smaller number of candidates to draw sweeping conclusions from. Still, it was interesting to note that this man experienced slight elevations in oral temperature, pulse rate, blood pressure, and respiration rate, subtle shifts in his physiological rhythms that took place soon after solar maximum too. Mirroring the women's experience, it's not just physical health, dear listener. There's even a subtle influence on the rate of mental disorders. A study in 2006 delving into the vast data of human experience looked at 237,000 clients in the main Medicaid database collected between 1995 and 2004, a significant snapshot of lives. They found that of all those clients, those born during higher energy, more chaotic solar cycles experienced an increased rate in mental disorders, a subtle echo of the sun's turmoil imprinted at birth. If this is truly the case, then the very cycle of the sun, the grand pulse of our star at the precise moment of your birth, might just in a profound and mysterious way have influenced the course of your life, setting a subtle predisposition. It's not quite star signs, not the rigid predictions of astrology, but perhaps astrology might just be onto something, at least, with one specific star, our very own sun. Ultimately, the science on this, dear listener, is still ongoing, still unfolding its secrets, a patient journey of discovery. And it should be stressed with gentle emphasis that any health impacts truly caused by these solar cycles are extremely minor, subtle whispers rather than loud pronouncements. As one researcher in a moment of humble insight put it, it took hundreds of thousands of patients, a vast ocean of data, to even notice that there was a health impact at all. So delicate are these connections. The sun cycle should not therefore prevent you from living your life, from embracing its fullness. As of the release of this gentle podcast, we're currently heading towards a solar maximum, that peak of solar activity predicted to arrive in 2025, a year just ahead. But for those who are perhaps worried, living through or being born in a solar maximum isn't all bad, not a cause for despair. The same study that hinted at health impacts also suggested with a hopeful whisper that this radiation might, in fact, lead to a rise in creativity and adaptability, perhaps unlocking new potentials within us. Perhaps it was during one such powerful cycle, 80,000 years ago, that a human brain, in a moment of profound mutation, was gifted with abstract thought and consciousness, the very capacity to perceive the universe and ponder its mysteries. If so, if these solar maximums indeed gave us the very means to perceive the universe, to wonder at its vastness, then we have much to thank them for. We wouldn't be us in all our complexity and wonder without them. The The sun isn't the only astronomical body that influences us, dear listener. Much like the sun, the moon, our silent, watchful companion, is an inescapable part of life on Earth. Its gentle presence, a constant in our night sky. The moon, in its quiet power, has an immense impact on our planet. You likely have already heard how its cycles subtly influence our wildlife, guiding their ancient instincts, how they gracefully affect our climate, and how most visibly they create the mighty predictable dance of the tides, shaping our coastlines with their rhythmic embrace. We tend to imagine that the moon and the Earth's gravities cause them to circle each other in a relatively stable synchronized harmony, a perfect unchanging duet in the cosmic ballet. But as is so often the case in the grand intricate tapestry of nature, reality is not as simple, not as perfectly serene as we might imagine it to be. Instead, every 18.6 years, with a quiet, persistent rhythm, the moon's orbit undergoes a subtle revolution, a gentle, almost imperceptible shift in its alignment between us and our radiant sun. This unique alignment causes high tides, those gentle swells of the ocean, to grow even higher, pushing them further up the shore, tipping us over the edge into dangerous flood territory. We've arrived then at our sixth cycle, a profound rhythm of our nearest celestial neighbor. Its name is the lunar nodal cycle, or with a more descriptive whisper, the precession of lunar nodes. This complex name refers to a specific intricate feature of the moon's orbit around the Earth. You likely know that every 29.5 days, the moon faithfully orbits the Earth, completing its monthly journey. However, this orbit is not flat, not perfectly aligned with the grand plane of the solar system. Or to be more precise, there is a subtle yet significant 5-degree difference between the angle of the moon's orbit and the ecliptic plane, that invisible two-dimensional plane on which the Earth gracefully orbits around the sun. For approximately half of each month, the moon in its silent journey is slightly higher than the plane of the ecliptic, hovering above it. For the other half, it gently drops below it, dipping beneath the plane. Naturally, this means that there are two specific crossover points, two invisible intersections, or two nodes, an ascending node, where the moon ascends above the plane, and a descending node, where it dips below. And it is these very nodes, these crucial points of intersection, that slowly, patiently move over the course of the 18.6-year cycle, gently rotating around the planet in one complete revolution, a grand unseen spiral. And it is these nodes in their subtle patient movement that are what ultimately causes the problem, the gentle escalation of tidal forces. To truly understand why, let's briefly recap what we already know about tides, that rhythmic breath of the ocean. You may already be familiar with how the moon's gravity, that invisible tether, gently pulls the Earth's vast waters towards it, causing a bulge in sea levels on the side of the planet closest to it. This visible swell of water is what we commonly call high tide. You likely also know, with a touch of quiet curiosity, that this phenomenon of high tide also happens on the side of the planet furthest away from the moon, seemingly defying the direct pull of gravity. Rather than being caused by a direct gravitational pull, this second bulge is gracefully caused by centrifugal forces. As the Earth and the moon in their cosmic embrace exert gravitational pull on each other, they behave somewhat like two dancers, holding each other by the arms and spinning across the dance floor. While it's mostly the moon moving, due to the Earth being much more massive, the Earth is also swung around a little, performing its own subtle wobble. The water on the side furthest from the moon is thus trying to fling off into space through its rocking, spinning motion, creating that second high tide, a beautiful push and pull. The sun, our radiant star, also has a profound role to play in tide formation, albeit to a lesser degree, a gentler whisper of influence. It's an immensely bigger mass than the moon, which would, in theory, cause a far greater pull if it were closer to us. But its far greater distance, its vast cosmic separation, means that the sun's overall effect on our tides is only about 1/3 as big as the moon's, a significant but secondary influence. However, when the moon and the sun are precisely aligned, when their gravitational whispers combine in a harmonious chorus, we get extra-large tides, immense swells of water that are powerfully known as spring tides. This powerful alignment happens 6 to 8 times a year, bringing with it some of the highest and lowest tides. Conversely, when the moon and the sun are not aligned, when their poles are at right angles to each other, they partially cancel each other out like two opposing forces, causing smaller tidal extremes, the gentler tides known as nape tides. So now, dear listener, gently consider the profound influence of the lunar nodes on this constant tidal tug-of-war. This delicate balance of gravitational whispers. During spring tides, when the powerful pull of the sun and the moon are working in perfect unison, combining their forces, this combination naturally causes the highest tides and consequently the largest risk of floods. This is the moment when the ocean's breadth swells to its peak. However, here's the subtle truth. The sun and the moon are never more perfectly aligned, never more harmoniously pulling in the same direction than they are at a node, one of those crucial intersection points of the moon's orbit. During the rest of each 9.3-year phase of the lunar nodal cycle, when the nodes are not aligned with the sun, the moon and sun are not quite tugging in precisely the same direction, and so tides are generally more temperate, less extreme, a gentler dance. But at a node, at that specific point of perfect alignment, that's where things get more serious, where the risk of floods becomes highest, as if the cosmic forces have conspired to raise the waters. The last time this precise alignment occurred, this powerful cosmic convergence, was in September 2015. Both the UK and the US, sensing the impending swell, issued major flood warnings to their citizens bracing for the waters. In September itself, there were floods certainly, but they were relatively minor ones, a gentle precursor. But it was only when heavy, relentless rain, combined with the amplified strength of the lunar nodes a couple of months later in December, that the real profound damage was inflicted, a powerful testament to the combined forces of nature. In the US, in October, South Carolina tragically saw flash flooding that caused widespread property damage and forced people to be rescued by emergency services, their lives suddenly disrupted. At the end of December 2015, the UK was hit by some of the worst floods it had seen in a century. Immense deluges that transformed landscapes. Combined with the relentless power of Storm Desmond, the extensive flooding and storm damage caused an estimated £1.3 billion in damages, a truly devastating economic and human cost. These floods, dear listener, can be highly damaging, their powerful waters reshaping landscapes and lives. But that in and of itself doesn't completely explain the quiet worry that NASA, with its far-seeing eyes, holds for the upcoming alignment in the mid-2030s. There is an extra element at play, a deeper layer of concern beyond the regular rhythm of this rising flood risk that we have been seeing through the course of human history. Unfortunately, the next node's alignment with the sun, that future convergence of cosmic forces, promises to be particularly devastating, a more profound challenge. The danger, you see, is that this natural phenomenon, this powerful lunar wobble, is combined with an already strained system, a planetary balance already under immense pressure, even more strained than it was in 2015. Over the last 100 years, we've witnessed steadily rising sea levels, a slow, relentless creep of the ocean's edge driven by a warming planet. When the next node aligns with the sun in the mid-2030s, this will likely lead to a dramatic, unprecedented increase of floods on planet Earth, pushing waters higher than ever before. Worryingly, a new study led by NASA's Sea Level Change Science team predicts with quiet apprehension that almost all U.S. mainland coastlines, along with Hawaii and Guam, will experience a huge leap in flood numbers when this happens, a pervasive surge. Some predictions based on careful models claim this node alignment could cause 4 times the amount of flooding from one decade to the next. A truly astonishing increase. This will inevitably damage vital infrastructure, reshape our coastlines around the world, and profoundly impact human life. Imagine the ripple effects: homes submerged, clean water supplies, disrupted electricity grids, failing plunging communities into darkness. Beyond the immediate chaos, there's also the increased risk of waterborne disease outbreaks, those silent, insidious threats like hepatitis A and cholera, as stagnant waters become breeding grounds for illness. Plus, the receding floodwater, as it slowly withdraws, can create stagnant pools, quiet, inviting havens where mosquitoes gather and breed, which can then spread other devastating diseases like malaria. This in turn has a profound knock-on effect on economic issues, as these powerful natural events can render coastal life unaffordable, making it difficult for communities to recover. There will be increased costs of insurance on these homes, or even worse, a complete inability to find insurance at all, which could cause a significant reduction in asset value in the community, a silent erosion of wealth. Consequently, this lunar nodal cycle, in its powerful manifestation, will likely damage the very quality of life in coastal communities, places where infrastructure may not be rebuilt or adapted to withstand this immense force of nature, forcing difficult choices and potentially mass migrations. It's not just bad for humans, dear listener. The delicate balance of ecosystems also suffers. Ilya Roslin, a visiting professor at Rutgers University, in his careful analysis, found that at the peak of the lunar wobble, where high tides are at their highest, these powerful surges can tragically drown salt marshes, those vital fragile ecosystems along our coastlines. Salt marshes are a crucial habitat for a vast range of species, from tiny invertebrates, those unseen creatures that form the base of the food web, to diverse fish and bird populations. And these prolonged floods, these immense surges of salt water, can indeed cause these delicate creatures to drown quietly, taking their lives. This means that other species like fish, seabirds, and countless others who rely on invertebrates to survive also profoundly suffer, their food sources vanishing. And they are not the only ones who rely on the silent wisdom and bounty of salt marshes, for these vital ecosystems hold a multitude of marine life, including astonishingly 75% of all fishery species, a true nursery of the ocean. This means that the lunar wobble, in its powerful embrace, impacts the food chains of both humans and animals, causing profound disturbances to their natural habitat and impacting their populations, a ripple effect that echoes through the entire ecosystem. While all of this, dear listener, does indeed seem fairly doom and gloom, a somber whisper of future challenges, it's interesting to note that not all ecosystems on the planet are negatively affected by flooding and high tides. Nature, in its boundless complexity, often finds ways to adapt, to thrive, even in the face of adversity. Ecologist Neil Saintelin of Macquarie University, in his insightful analysis, found that the lunar nodal cycle, with its rhythmic pulse, heavily impacts the expansion and contraction of mangrove canopy cover over most of the Australian continent, those resilient coastal forests. His analysis beautifully showed that the peaks of the lunar nodal cycle, those moments of highest tides, consistently coincided with the flourishing cover of the mangrove canopy, a clear, harmonious link. It showed that when the lunar wobble is at its minimum phase, when tides are less extreme, it causes the mangrove ecosystems to become very dry, their roots yearning for moisture, which sadly leads to thinner canopy, cover, a more sparse embrace of green. Yet when the lunar wobble is at its maximum phase, when the tides swell to their highest points, mangrove cover dramatically increases their roots, nourished by the constant influx of water. A beautiful testament to their unique adaptation. Mangrove canopies, those vibrant green guardians of the coast, are profoundly beneficial to Earth's environment in myriad ways. They are complex ecosystems rich with life that actively fight against climate change, absorbing vast amounts of carbon dioxide. They protect precious wildlife, providing vital habitats for countless species. And crucially, they shield coastlines from the relentless assault of waves and storms, acting as natural living barriers. They can also remarkably absorb 4 times as much carbon dioxide than rainforests of the same size, making their growth vital to the welfare of our planet, a powerful ally in the fight against a warming world. So it's not all downside, not all somber whispers of challenge. Still, it's clear that if we don't plan ahead, if we don't prepare ourselves with wisdom and foresight, coastal cities and environments around the world will face a serious crisis, a profound shift in their very existence. Your important question then, dear listener, is what can we as a species gently do about it? What wisdom can we draw from nature's lessons to prepare for these challenges? One powerful method, a natural shield, is better protection working with nature rather than against it. As mentioned previously, the protection and restoration of mangroves can act as a living shield against flooding their intricate root systems and dense canopies, mitigating the vulnerability of communities on the coastlines. More specifically, mangroves can avert immense damage by decreasing the height and energy of incoming waves as they pass through dense mangrove forests. The above-ground roots and tangled branches of the mangroves diminish the height of the waves, absorbing their destructive energy, and thus, the waves lose energy, their power dissipated. This ultimately stops the waves from emerging onto the seabed with full force and engulfing the delicate sediments, preventing erosion and destruction. The mangrove's dense roots and branches also significantly reduce wind energy, which can further stop the formation of large destructive waves, calming the storm's fury. According to careful reports, densely packed mangroves, those vibrant green fortresses, can have the height of a wave through just a 100-meter passage, an astonishing feat of natural engineering. For comparison, in an open forest, where roots and branches are more sparse, it would take a vast 500 meters for a wave to have its height, highlighting the incredible protective power of dense mangroves. So the preservation of existing mangrove forests and the active reforestation of new ones or other plants with a similar capability can become a great living shield against upcoming floods, a testament to nature's protective wisdom. Another possible solution, another path forward, is to learn how to gracefully live with these flood-heavy conditions, to work in harmony with nature rather than futilely fighting against it. For example, let's take a quiet look at the remarkable flood defenses in the Netherlands, a country where a significant 1/3 of the land is below sea level and another third is perpetually at risk of flooding, a constant dance with the ocean. They've built intricate infrastructure that beautifully works with water and manages the rising sea levels rather than simply trying to hold them back. They achieved this remarkable feat by designing ingenious facilities like polders. Polders are bits of land carefully reclaimed from a body of water that lie below sea level. They are always fully or partially surrounded by an embankment, a protective wall, to diligently keep the water out, whether it comes from the vast, restless sea or a flowing river. These polders offer an intricate network of drainage canals and pumps to meticulously manage water levels, disposing of excess water, and gently running water back to the sea or river to make sure that the water doesn't run over land, preventing devastating floods. Polders can be used to protect houses, farms, and factories, vital components of life, and thus are used extensively around the country, a testament to their effectiveness. The Netherlands also built massive dams and ingeniously utilizes sand dunes, those natural barriers of the coast, to create ways to stay dry in their swampy land, adapting to nature's conditions, rather than battling them. This beautiful example shows that there are indeed ways in which we can observe nature, learn from its ancient wisdom, and live alongside it in harmony, adapting to its rhythms. So, dear listener, the bad news, if we can call it that, is that behind its ethereal beauty, our silent moon hides a powerful force. This power, if just so combined with other planetary shifts, is set to overwhelm humanity's coastal settlements, posing a profound challenge to our very way of life along the shores. However, there's always a bit of good news too, a whisper of hope in the face of adversity. For knowledge in its very essence is a power of its own. By understanding our plight, by recognizing the challenges before us, we can bravely look for solutions both among already existing ideas, those ancient wisdoms, and new ways forward, that have yet to be discovered awaiting our ingenuity. If we are to truly enjoy what is coming, if we are to gracefully navigate these future challenges, it's high time for us to use our innate creativity and our powerful drive to adapt and survive to work with our planet rather than stubbornly against it. So here comes the moment of truth. Dear listener, how do all these natural cycles, these grand rhythms we have explored, stack up to mankind's impact on our climate? These cycles in the patient position of the Earth, in its cosmic dance, in the subtle ebb and flow of its winds, in the deep churning heart of its fiery core, and in the far-reaching invisible influence of its celestial neighbors, the sun and the moon, all have a profound, undeniable influence on the planet we live on. They move in rhythms that are predictable and solid, like ancient clockwork, even if they sometimes take place over time spans that are so immense, so vast, that we don't always live to see them fully play out within the brief scope of our human lives. Once we begin to truly understand them, our understanding of our planet deepens. Our connection to it becomes more profound. We are able to predict what's coming, whether it's the gentle swell of floods, the furious dance of hurricanes, the quiet despair of droughts, or the blessed years of plenty. But there is something else happening to the Earth, dear listener, something that we did not fully expect, something that does not line up with any of these other grand ancient cycles, a new rhythm in the planet's song. It is something many believe that we may have to bear responsibility for a profound echo of our own presence on this planet. It's getting hot outside nowadays, isn't it? It's difficult indeed to turn on the news or open a paper without hearing someone talking about global warming. Its very name now a familiar hum. Headlines are constantly filled with references to steadily rising temperature levels, to the burning of fossil fuels, and to an encroaching, unsettling danger. And the discussion around the subject, the very conversation about it, has often gotten as heated, as turbulent, as the weather itself, filled with strong opinions and passionate debates. This has been a topic I've been wary about weighing in on simply because of how sensitive a subject it has become in recent times, how deeply it touches so many lives and beliefs. I didn't want to simply create more noise, more static, in an already crowded conversation. However, dear listener, I do now think there is something worth adding to the discussion, a quiet perspective that can bring clarity. After all, there is plenty we hear about the current temperature of the planet, its rising fever. What is often not talked about, what sometimes gets lost in the noise, is the profound patterns of temperature change that existed in the past, the Earth's ancient climatic history, which beautifully contextualize that modern temperature. Are we, in truth, the hottest we have ever been in the vast, long history of this planet? Scientists believe with strong evidence that in the last 100 years, the global temperature has been steadily increasing, a measurable rise. But how does this current rapid increase fit into wider patterns and trends of the Earth's climate? And how, we might gently ask, did they even find any of this out? How did they uncover such ancient truths? Well, to answer that profound question, we need to know what the temperature used to be to glimpse the Earth's past moods. It's easy, relatively speaking, to find the current global temperature today. All you need is a thermometer, and you can simply go outside and take a reading, a simple observation. With enough readings taken at different locations around the globe with careful data collection, you can find a reasonably accurate average temperature for the whole planet. Scientists have actually been diligently doing this since 1850, meticulously recording the Earth's daily breath, meaning that our records on average global temperatures are fairly accurate since this date. However, dear listener, mercury thermometers, those clever instruments, were only invented in 1714, a relatively recent invention in the grand scheme of time. So how then do we know what the temperature was before these global readings started being taken? How do we, with our modern curiosity, know the temperature 1,000 years ago when civilizations were rising and falling? Or even 1,000,000 years ago, long before humans, as we know them, were even on the scene walking upon this earth? Some of you with your discerning minds may already know the answer, or at least a partial answer to this profound question. Scientists can approximate global temperatures in the past through a fascinating technique called ice coring. Imagine drilling deep into ancient glaciers, those vast patient rivers of ice, and extracting long cylindrical samples. Essentially, when snow gently falls, because it is powdery and soft, it traps tiny delicate bubbles of air where it lands, preserving a snapshot of the atmosphere at that moment. If this snow doesn't melt, but has more snowfall gently accumulate on it, later burying it deeper, such as in a very cold, perpetually frozen place like a glacier, you can end up with distinct layers of snow and ice, with countless trapped air bubbles going back for many, many years, even millennia. It creates something similar to the beautiful concentric rings on an ancient tree, each ring telling a story of time. By carefully collecting ice formed in this way, scientists can take sections to a lab and patiently melt it, releasing the ancient air relating to specific years. Like unlocking tiny atmospheric time capsules, they then can meticulously measure the different ratios of gases released from these air bubbles, which tells them the precise atmospheric composition at that ancient time. And because we can precisely test how much heat is retained by a gas when exposed to a constant temperature like the sun, for instance, knowing that CO2 retains more heat while oxygen retains less, with enough samples, scientists can calculate roughly what the global temperature was during that year, reading the quiet whispers of the past. However, the oldest glaciers we can study, these vast frozen libraries, are only 1 million or so years old, a mere blink in geological time. To get a truly good idea of the profound trends that govern global temperatures, to understand the deepest rhythms of our planet's warmth and cold, we're going to have to journey back much, much earlier than that, far beyond the reach of ice. How then do we know what the global temperature was over 1 million years ago? The answer, dear listener, might beautifully surprise you. Clams. Actually, not exactly clams, but something wonderfully similar. The answer to how we know global temperatures from over 1 million years ago lies not with clams, but with something wonderfully similar. A tiny, exquisite, single-celled organism, no larger than a full stop on a page, called foraminifera. Like clams, these delicate organisms produce beautiful shells around themselves, intricate miniature homes. And these shells in their quiet design are slightly porous, allowing the subtle passage of elements. Oxygen in particular is gently taken into the shell and then with remarkable precision, trapped there, remaining perfectly in place even when the foraminifera dies, its brief life cycle complete. So by using a similar process to the ice cores, we discussed if patient scientists can find these ancient shells of dead foraminifera from a particular year. Perhaps millions of years ago, they can with careful scientific artistry release that trapped air. From it, by meticulously analyzing different oxygen isotopes within the shell. Rather than air composition, they can work out with surprising accuracy the global temperature of that distant time, reading the quiet whispers etched in the ocean's depths. Foraminifera, in their humble resilience, are still around today, thriving in our oceans, and they first came onto the scene a staggering 500 million years ago, making them instrumental in helping us get a clear, profound picture of global temperatures during this much longer time period, reaching back into the planet's deep ancient past. But what, dear listener, does that picture reveal, that vast panorama of Earth's ancient temperatures? Well, perhaps unsurprisingly, the Earth's temperature has undergone significant dramatic changes over the last 500 million years. A grand continuous dance of rising and falling, warming and cooling repeatedly. At times, it has faced temperature averages an astonishing 14 degrees Celsius hotter than we experience today, a world of almost unimaginable heat. And at other times, it has been profoundly colder, about 5 degrees Celsius, lower than our current average, plunging into deep, widespread chills. So no, we are not in the grand sweep of geological time the hottest we have ever been. That perhaps is not surprising to anyone who knew that the very surface of the Earth, when it was just newly formed, a fiery infant planet, was mostly magma, a molten, glowing orb. But what is truly fascinating is the sheer number of fluctuations that have occurred over these millions of years. The countless peaks and valleys, a surprisingly intricate and dynamic climatic history. Why, we might ask with a gentle curiosity, are they happening? Scientists, with all their profound knowledge, are not entirely sure, for there doesn't seem to be much of a simple discernible pattern to them. On the grandest scales, no obvious rhythm to their vast movements, but they believe that some of these profound fluctuations are intricately linked to the emergence of new life forms, to the silent, transformative power of evolving biology. For instance, the majestic arrival of plants, those patient green producers at around 450 million years before the present, might beautifully explain why the global temperature dropped so noticeably then. They began in their quiet, photosynthetic revolution, absorbing vast amounts of atmospheric CO2, that warming blanket, and transforming it into oxygen, a gas that retains less heat. It was a profound shift in the Earth's atmosphere driven by life itself. Other changes, other subtle shifts in temperature could have been caused by plate tectonics, the slow, inexorable movement of Earth's great crustal plates, and intense volcanic activity, spewing forth vast amounts of CO2 into the air, warming the planet. And still other changes, more sudden and catastrophic, could have been caused by possible meteor impacts, like the colossal one that tragically wiped out the dinosaurs, plunging the world into a new era. However, this, dear listener, is not the full picture, not the entire grand tapestry of Earth's climate history. Within these vast overarching fluctuations, these slow, immense swings of temperature are smaller, yet still profound fluctuations. Rapid rises in global temperatures, swift surges of warmth, followed by gradual patient dips, slow returns to cooler conditions, hundreds of them woven into the fabric of time. It's hard, isn't it, to truly get your head around the sheer scope of Earth's history, the vastness of its journey. But each one of these dips, each gentle descent into cooler conditions, represents entire ice ages periods when vast sheets of ice covered significant portions of the Earth. Ice ages are technically defined in the language of science as any point in Earth's history where there is ice on the polar caps, something that is surprisingly not always the case. So technically, as I've mentioned previously, we are in an ice age right now, as ice still covers both poles. However, although the general trend of the Earth's temperature at the moment, in the long, slow cosmic view, is towards ice ages, towards a cooler overall state, we are currently in something special, something known as an interglacial period. This is a brief, precious moment of warmth, a gentle respite that lasts for a few tens of thousands of years or so, bravely interrupting a deeper, more general, long-term cold trend. In the last full ice age, the polar caps, those vast white expanses, reached as far south as the UK and parts of the US, truly reshaping the landscape. Some of these peaks and valleys in global temperature, these gentle rises and falls, are predicted by the grand cosmic clockwork. They correspond beautifully with Milankovitch cycles, those patient, powerful drivers of climate arriving in their precise rhythms every 23,000, 41,000, 100,000, 405,000, and 2,400,000 years each period, bringing its own subtle influence. As they gently cool, the planet ice begins to form slowly but inexorably, painting the world in white. But in the last 10,000 years, something truly unprecedented, something entirely new has occurred. As I mentioned, we have gracefully risen out of an ice age, emerging from its icy embrace, and have entered an interglacial period. For the last 10,000 years, this period has been a remarkably stable plateau of global temperature, a consistent warmth, like a long, gentle breath. This stability is perfectly consistent with the pattern you might expect, as Milankovitch cycles are slow things, their influence unfolding over vast stretches of time, like the gentle trickle of a stream that eventually erodes a mountain. All of human history, from the silent majesty of the pyramids to the bustling present day can be found on this most recent plateau of stable warmth. Although humans existed before this point, before this period of stability, they hadn't really got the hang of building any complex civilizations living a more nomadic existence. Scientists have aptly named this plateau, this cradle of human civilization, the Holocene period. However, dear listener, right at the very end of this 10,000-year period, this long stable breath, there is a sudden and remarkably rapid uptick in global temperatures, a sharp, surprising rise. This is very unusual, a sudden spike that stands apart from the gentle long-term rhythms of the past. This uptick, this recent surge, represents a rise in the global temperature by 1 degree Celsius, a significant measurable change, which technically is still roughly on par with the interglacial period before our current one over 100,000 years ago. So, the absolute temperature itself is not entirely unprecedented. However, it is not the magnitude of the temperature change that is truly concerning about this uptick. It is profoundly how quickly it is rising. Unlike all the other changes I've talked about which have patiently taken place over hundreds of millions of years at the longest and thousands of years at the shortest, this particular rise took place in a mere 100 years. Imagine that 1 degree Celsius in just 100 years, a pace utterly foreign to the Earth's ancient rhythms. This rapid acceleration could have a profound disruptive impact on the delicate ecosystems on the planet, as life in all its wondrous forms struggles to adapt to changes. This rapid, this sudden. So, dear listener, what could have caused this unprecedented uptick, this sudden surge in warmth? The answer cannot be Milankovitch cycles. For as you have learned, these cycles take place on the scale of thousands of years at the very least, and millions at most. Milankovitch cycles are beautifully described as weak but consistent forces like the gentle, persistent trickle of a stream that eventually over vast time carves out a mighty canyon, slowly eroding a mountain. They do not by their very nature create profound effects over such a small time frame as 100 years. Similarly, there has been no cataclysmic event, no sudden devastating asteroid impact, such as the one that tragically wiped out the dinosaurs, which might be our other explanation for such a rapid shift. That meteor, a colossal force, was thought to be 10 kilometers wide and struck with a force equivalent to 21 to 921 billion Hiroshima A-bombs, an unimaginable explosion. About 75% of species tragically died in the profound climate change that happened in its aftermath, a silent, vast extinction. If something of that magnitude had hit Earth since 1850, we would have certainly noticed it, its impact undeniable. None of our other cycles, the sun, the moon, El Niño, or the polar vortex, can account for temperature rises like this either, or rather, their influences are already accounted for in the broader models. El Niño, for instance, is understood well enough that we can tell this current rapid warming has nothing to do with its recurring patterns. This is not due to the cycles of the sun or the moon or the internal dynamics of the Earth itself. However, dear listener, there is one factor, one significant element, that does indeed beautifully explain this rapid change in global temperatures, this sudden, sharp uptick. It is the activity of humans. It is not, we must remember, the first time that living organisms have had a profound impact on the global temperature, reshaping the very atmosphere of the planet. Remember, it is widely believed that some of the grand ancient changes we see in Earth's climate history were caused by the introduction of plant life, those patient green producers which slowly began absorbing CO2 and releasing oxygen, fundamentally altering the atmosphere. Similarly, much further back in time, when life was still all single-celled organisms, simple and microscopic, about 2.4 billion years ago, the remarkable arrival for the very first time of cyanobacteria that could photosynthesize had a massive transformative impact on the atmosphere. For the first time, an organism began putting vast amounts of oxygen into the atmosphere, a revolutionary change. This occurred at such a rapid, unprecedented rate that there was a profound event known as the Great Oxidation Event, which chillingly coincided with a significant dramatic drop in the global temperature. Some scientists believe the entire world almost froze entirely over becoming a vast frozen orb, as there is compelling evidence of glacial activity at the equator, a phenomenon vividly known as a snowball Earth. What we learn from this, dear listener, is that the balance of global temperatures, the Earth's delicate thermal equilibrium, is incredibly sensitive, incredibly precarious. A single species, if it begins to change the atmospheric ratio of gases, if it begins to alter the very composition of the air, can have a massive, profound impact, fundamentally reshaping the planet's climate. It can, in its pervasive influence, overload the subtler, more patient effects of Milankovitch cycles, those grand slow forces pushing the climate system into an entirely new trajectory. And since 1850, since the dawn of the Industrial Revolution in 1760, humanity, with its burgeoning activity, has indeed profoundly changed the way we have been interacting with the atmosphere, altering its very breath. Unlike the previous roughly 10,000 years of human history, the long stable Holocene period industrial activity and farming have produced vast amounts of greenhouse gases as a waste product, like an unseen accumulating blanket of warmth. In the last 4 decades, with a sobering predictability, each decade has been the hottest decade on record since we started diligently tracking global temperatures in 1850. CO2 levels, those invisible warming gases, are now at a global average of 410 parts per million, and methane, an even more potent warmer, at 166 parts per billion, which is higher than we have seen in the last 800,000 years, meaning since before about 8 ice ages, and the interglacial periods between them, a truly unprecedented concentration. All this extra heat, this accumulating warmth, has a profound impact, creating its own set of feedback loops, spirals, of self-reinforcing change. Let's talk about wildfires, those raging infernos that consume vast landscapes. Earth, in its vastness, has an awful lot more carbon stored within it than what currently exists in the atmosphere. But the vast majority of it is stored patiently in either the ground, held within the soil, or in the silent depths of the deep oceans, or in biomass, the living matter of our planet, which includes our magnificent trees, the tiny, unseen phytoplankton, countless plants, and all animals. Sadly, vegetation is drying out around the world, its lifeblood slowly draining because of persistent drought and increasing heat. This means it is more susceptible to fire, more prone to ignition, transforming into a vast, flammable tinderbox. There is a specific biome on Earth, a vast ecological region called the taiga or boreal forest, a cold-resistant realm that stretches across immense expanses of Canada and Russia. It is the second largest biome on Earth after the oceans and consists mainly of coniferous forests, those resilient, cone-bearing trees. In 2014, a massive fire ripped across a section of boreal forest in Canada's Northwest Territories, consuming an area the size of Maryland, or 7 million acres, a truly colossal burn. These fires alone, in their destructive fury, released 94.3 teragrams of carbon into the atmosphere, which is about 103 million tons, an astonishing amount. This meant that this single fire released half as much carbon back into the atmosphere as all the plants and trees in Canada typically absorb in an entire year, a truly profound imbalance. This, dear listener, creates something of a feedback loop, a vicious circle of warming. The more CO2 released into the atmosphere, the worse the frequency and severity of wildfires become, those raging infernos consuming more land. And the more CO2 gets released from the burning vegetation, further exacerbating the problem. Biomass burning, the consumption of organic matter by fire, currently accounts for a significant 30% of total carbon dioxide production across the world, a sobering contribution to our warming planet. But as the Arctic, that frozen sensitive realm, is warming faster than any other region on Earth, these fires, these consuming infernos may increase even further in number and intensity, becoming even more powerful. In 2016, 8.6 million acres burned in the Russian taiga, a vast, silent destruction. And on a more direct human level, let's not forget about the devastating wildfires a few years back that happened in Greece, the US, and other places worldwide that have directly brought tragedy to countless people, their lives and homes consumed by flame. The issue with trees burning is profound. They release a lot of the carbon they absorbed back into the atmosphere, undoing their vital work of sequestration. That land will also take a long while to regrow, decades, as trees take many years to reach maturity to regain their full carbon-absorbing capacity. While these forests are regrowing, they are not at the same capacity they were. In 1988, a wildfire swept across much of Yellowstone National Park, damaging 36% of the park, a vast scar. Less than 30% of the burned area regained full forest cover 20 years later, a slow, arduous recovery. Let's recall for a moment the Australian forest fire that took place from late 2019 to early 2020. It was immense, a truly colossal event. On the 30th of December, smoke from the fires could already be seen. From space, a vast brown plume spreading across the continent. Their telltale brown hue visibly separated them from the white, fluffy water vapor clouds, alongside them a stark, sobering contrast. The fires burned throughout the night, relentless in their fury. And when the morning came, there was already a noticeable, terrifying increase in their size, their destructive reach expanding. It was on this very day that the military was deployed to some cutoff regions, their swift intervention necessary to assist the evacuation of trapped civilians' lives hanging in the balance. The smoke trail by then reached across the Pacific Ocean for at least 1,000 kilometers, an astonishing testament to the scale of the disaster. Fires continued to burn through the night, a relentless inferno, and in the morning, it became clear that the wind had shifted, taking the smoke in a more easterly direction, completely blanketing neighboring New Zealand, shrouding its pristine landscapes. Sydney, too, a bustling metropolis, was completely covered by smoke, a choking, pervasive haze. This reduced visibility, greatly making even daily life difficult. But it also tragically reduced the quality of the air for people breathing, a direct health threat. Sydney had the worst air quality out of any city on Earth, during this time a sobering record. In the end, smoke from the fire was thousands of kilometers long, a vast atmospheric scar. Wildfires are indeed a natural occurrence in Australia, a part of its ancient ecological rhythm. However, none have been seen on this scale, never before in recorded history, a truly unprecedented event. But it's not just forest fires, dear listener. The global cover of surface ice, those vast shimmering expanses of white, has been retreating consistently since 1950, a measurable, undeniable decline. This is something scientists do not believe to have happened for the last 2,000 years, making the current rate of ice loss unique in recent history. As you will recall, this has a profound knock-on effect on Milankovitch cycles, those grand slow drivers of Earth's climate, because a planet with less surface ice does not reflect as much heat from the sun. It therefore tends to get even hotter, absorbing more of the sun's energy. Like pushing a cart down a hill, these changes have a certain amount of momentum to them, a self-reinforcing push. And sadly, rapid changes in global temperature, these sudden, swift surges of warmth, tend to lead to species going extinct, their evolutionary clocks unable to keep pace. It normally takes thousands of years for life to adapt to the profound conditions you might find during an ice age, for creatures like the woolly mammoths to evolve the traits needed to thrive. And it takes thousands of years for them to adapt to conditions today for elephants to thrive in warmer climes. Natural selection. You see, that patient, intricate process of evolution takes time to develop in a species the specific traits they need to thrive in a new environment, to adapt to changing conditions. If species are not given this crucial time, if the changes are too rapid, they either have to migrate to a new environment, better suited to them, a desperate search for comfort, or they will simply die out, their ancient lines coming to an end. As the habitable zones, those regions where life can comfortably exist, begin to migrate towards the poles, some zones will tragically vanish, completely dissolving into uninhabitable conditions, while new hot desert environments utterly inhospitable will be created, and life in general is poorly adapted to such extremes. It's important to note, dear listener, that these events, profound as they are not unstoppable. Global temperature change does indeed have some momentum, a certain inertia to its movement. But if we as humans find ways to stop changing the atmosphere's ratio, if we cease adding to that warming blanket, then in time, Milankovitch cycles, those ancient patient rhythms, will take over again, and the rapid rise will eventually stop returning the planet to a slower, more natural rhythm. That's why it's so incredibly important for governments around the world to listen to reports by institutions like the IPCC, the Intergovernmental Panel on Climate Change. The IPCC is an international group of scientists diligently funded by multiple governments, tasked with the vital mission of finding out the scientific realities of climate change to bring clarity to this complex issue. In 2021, they released their 6th assessment report explaining the physical science basis in profound detail. In it, they unequivocally stated that it is indeed human influence that has warmed the atmosphere, ocean, and land, a clear, undeniable fingerprint on our planet's climate. However, they also offered crucial suggestions, pathways forward, namely the immense importance of halting or rapidly reducing CO2 emissions towards net zero, as CO2 is the largest contributor towards climate change, followed by methane. They also recommended the development of carbon dioxide removal facilities to be established worldwide, new technologies to actively remove warming gases from the air. Some of these are already in operation, such as Project Longship in Norway, a tangible step towards a solution. Their aim is to gently take CO2 out of the atmosphere and bury it beneath the ground, safely storing it into depleted fossil fuel reservoirs, a long-term solution. The IPCC says that actions like this, if widespread enough, if implemented on a truly global scale, will reduce global surface temperature and even reverse certain other processes, like the acidification of the oceans, healing some of the wounds we have inflicted. Personally, while I find current carbon capture projects fascinating in their ambition, and they do indeed exist and are slowly growing, the scale of the challenge remains immense, a daunting mountain to climb. But these efforts, whatever their form, truly need to be done on a large scale, government level, a global collaborative effort. Ultimately, dear listener, my aim for the end of this gentle podcast was to examine what global warming truly meant within the grand, profound context of the Earth's wider history. From it, we can realize that it's not actually accurate to say that we're the hottest we've ever been, a simple truth that is often misunderstood. And I find that a really fascinating insight, a gentle correction to a common misconception. However, that fact alone is not the reason some people think it is to simply not worry about the problem. Climate change, in its natural course, is a process that usually takes millennia, unfolding slowly over vast stretches of time. What I've realized, what has become clear in this exploration, is that the worrying part is not necessarily the change itself, not the fact that the Earth's temperature fluctuates, but rather, it is the astonishing speed at which it is happening, a pace utterly foreign to the Earth's ancient rhythms. Some life forms in their slow, patient adaptation might get left behind, unable to keep pace with the rapid shifts. And how will humanity in all its complexity truly cope? We don't know, for we haven't been around long enough in our current form to deal with the extremes of the past, to witness such rapid, profound shifts. While human activity has indeed sped up certain elements, accelerating the natural processes, and while we can certainly undo some of what has been done through our actions, now through conscious choice and concerted effort, some things like higher sea levels will be with us for up to 1,000 years. According to the latest IPCC report, a long-term consequence. We are, according to the IPCC, past the point of no return for limiting warming to 1.5 degrees Celsius, a sobering threshold. And we will need to make rapid fundamental changes to our society this decade to stop it going any further than that a monumental task. This will be hard, dear listener, incredibly challenging. There's no way we as a species will be able to achieve this hard path, this difficult but necessary transformation, unless we can agree on the fundamental facts that underpin it, the shared understanding of the problem. Without the broader context of agreed-upon data, without a common ground of truth, it will forever be perfectly possible to arrive at a wide range of conclusions, to envision many different paths we should take. That is why, when it comes to any discussion, any conversation about our planet context is so important. For it provides the lens through which we can truly see. By looking at the vast, profound pattern of our planet's history, by listening to its ancient whispers, we can be sure that the current uptick in global temperatures, this rapid surge, is an induced event, a new rhythm that doesn't match already existing patterns. And it perfectly coincides with sobering clarity with human activity. Debate what you want to do with that information, dear listener, and the best path to take in light of it. But these are the facts set in the silent wisdom of ice and the ancient bones of organisms long dead. They will brook no argument. Ultimately, Earth cycles in all their intricate beauty are all around us, constantly shaping our world. They rise and fall, compounding with each other at times, their forces combining, and at others working in opposition, canceling each other out. While their extremes can be destructive, bringing challenges and hardship, by learning about them, by patiently understanding their rhythms, we can learn to live with them, to adapt to their powerful embrace. And they certainly make sure that life on Earth is not boring, but a constant dynamic adventure. We as humans are now part of that process, part of that grand unfolding story, whether we fully grasp it or not. Although whether we will prove to be cyclical too, whether our presence on this planet will also follow a predictable rising and falling rhythm, remains to be seen. Perhaps our mastery of this planet will continue to increase until these cycles are no match for us, and we will be able to set the weather and the temperature to whatever we want it to be in a given moment, a true dominion over nature. But those days, dear listener, are a long way away, a distant dream. For now, it's important to understand the cycles of the planet and how we are influencing them. Because whether we are ignorant of them or not, whether we choose to acknowledge them or not, they will profoundly influence us. At least now, when someone offers you a polite conversation about how is the weather, you know enough to take it a little farther to offer a deeper insight, tell them gently, "Too easy. I can tell you why the weather is the way it is." They may or may not appreciate that answer, and it might be the end of the conversation, but in my humble opinion, it's a fascinating topic to know about, a profound truth to hold. Well, that's all we have time for today, dear listener. I hope you've enjoyed listening to this slightly longer podcast on the cycles of the Earth, a gentle journey into our planet's rhythms. If you've enjoyed what you heard, please feel free to follow us for more podcasts on other fascinating space topics as we continue our exploration of the cosmos. But for now, I'm your gentle guide, and this has been a quiet contemplation of the Earth. All the best, and see you next time.